Alright guys, welcome to day 16 of Project Dig. Thank you for joining. I appreciate it. We just wrapped up our recap video that I'm going to be posting on YouTube. Hopefully you guys didn't find that too confusing. All the new people coming in are like, wait, what's going on? What's happening? But yes, welcome. I hope you all are having a good day so far. Smile. Take care. Have a good night. Hey, Flint Steel, and Boo, and Natsu. Jay Cummins, what's up? Hello to all. Yes, so just did a recap video, going to post that. And before we really get into development, I want to talk about some stuff. But first, I'll just say we're going to be doing physics today. Yesterday, we aspired to do the physics, but then got distracted with doing an active component pool, which just allows us to partition our component pool into active components at the front, and then inactive components after that, and then even after the inactive components we have all of our unused components. And so this will be useful for probably mostly physics components, which will be going to sleep and then waking up, going to sleep, waking up. And so we just want to move it around in this component pool, which is fairly quick to do, as opposed to iterating over a bunch of components that we're not using. Usually, like, it will change fairly often, but it often will also stay in one state or another. So I think this will be the most efficient way. We can always try other things. Like, in the future, maybe we could try, and it should be somewhat trivial to do this, is just add in a render component, a physics component whenever it's active, and remove it whenever it's inactive, and see if that's more performant. And yeah, it shouldn't be too hard to try to profile something like that. Hey, Dodge Whale, what's up? Hello, hello. Yeah, so that's what we worked on yesterday. Now we're going to do physics today. Before we get into that, I wanted to talk a little bit about open source stuff and kind of the Patreon thing, but mostly the open sourcing stuff. We've talked about it the last few days, and I actually was digging into it for a while last night. So we've talked for a while about trying to get this code open sourced somehow. I'm still not 100% sure on it, but here's what I'm thinking. I got a GitLab set up, and I have the projectDIG on here. Hey, S8er, I'll try to reply in a bit, despite the fact that it's fun watching your stream. Hey, awesome, Boo. Open source, yes, open sourcing it. So, I have a lot of thoughts going on about this. I want to do it. But there's some complications, mostly whenever it comes to gameplay systems and game content. So here's what I'm kind of thinking right now. Well, so right now we're not going to be doing that, and we're probably not going to be doing gameplay systems and content for a while. If we look at our roadmap, you'll see that like I kind of marked all this orange or kind of almost gold is gameplay system. So that's stuff that's kind of a little bit more specific to the game. You'll see most of it falls at the bottom and the majority of this stuff is up at the top. Can't you just open source the engine? Yeah, so that's kind of what I'm thinking I might be able to do, and I have some thoughts on how I could do that. We all know that all your code comes from Stack Overflow. That's right. I'm just copying and pasting. That's what we'll be doing today with the Box2D and this. We'll just copy it over. Yeah, so I want to open source this stuff. What I'm thinking for now, what I might do is do the same thing that Handmade Hero is doing, which is open sourcing the engine through like backers or supporters, and that's where like the whole Patreon things comes into play. I'm thinking about doing it for the robot thing. I think, yeah, that's right. And then also Thin Matrix does this with his Patreon. Yeah, his is $12.50. I was doing powers of 2. I don't know. I was just but yeah, so I haven't posted anything yet. I'll post a recap video up here for sure. And I'm planning on doing more content, so I am looking for feedback on this Patreon stuff. I like powers of 2, yeah. Oh, this is currently private, this repository. So what I'm thinking about doing is making it so that you can get access to it. I can add people as like collaborators or whatever. If you're robot tier. And then I was kind of thinking in the future, maybe at a certain goal, I need to change these goals some. I can make it so that the entire thing becomes open, and then what I was thinking about doing is possibly making it so that then at that point the robot tier could get access, and hopefully it lines up to be this way that we would start working on the gameplay systems at that time. And the robot tier would then, you know, since I would open source the entire engine to everyone, robot tier would have access to the actual gameplay systems, but it would be a much more restrictive license. Incredible profile picture. Thanks. Hey Jeremy, what's up? So I was actually playing around with this, and I'm not sure what I want to do with this yet. I might change the license because of that. So I basically took the MIT license and modified it such that you can't distribute it. I just added in this little clause where like I changed it so that I might need to actually remove the sub-licensing part, but that you can't distribute it you can't sell any derivatives of the work. And so I added that in, but I was thinking like I could do this for the gameplay content. I probably wouldn't never release the assets, but so like the gameplay system, so you know the I don't know exactly what that would be, to be honest. Maybe the cellular automata stuff, and oh whoops, I have 2 open. You know, maybe some more game specific stuff, like possibly the UI and so on. I'm not sure. And I would definitely ask for you guys' opinions on what we should keep and what we shouldn't. And I need to look at all the licenses from the libraries that we would be using. And yeah, so like maybe something, so like possibly stuff like the power system or mechanical wiring, which is like very game specific, or the operation programming. Maybe I wouldn't ever release that stuff. So it might be a question of like what goes where. I'm not sure yet, but we have a while to get to that point. I was just wanting to see what you guys think. I don't know why I have two of that. I think it's easier if you just open source the engine, but even if you release it that way, it's still a trust issue, isn't it? Well, I mean, at least at this point, and I would probably talk, before I would release any gameplay specific stuff, I think I would talk to a lawyer, like hire a lawyer and get their advice on it and make sure that I have my bases covered, so that way if someone did like just try to rip off the game using the code, well, like the engine, I'm fine if people use it. Like if someone wants to use the ECS or like this very primitive physics system, I'm okay with that. It's more of whenever someone's like, yeah, I'm going to take this power and production system and turn it into my own game, and then I'm like, well, that's very specific to like yeah, but like maybe some more generic stuff can go in the core engine, like equipment or like status effects maybe. I'm not entirely sure about that stuff. And as we get further into development, we could talk about what could go where. It would be a good way to sustain yourself and also get feedback on the game maybe. Or even get collaborators that way. Yeah. I don't know if I want to open source it in such a way that I'm accepting. Actually, I'm like positive I don't want to do that, because then that gets really complicated and also it kind of defeats the purpose. So I'm not going to be accepting commits or like pull requests. It would be a one-way thing where I'm working on the game engine and someone, if they want, can use parts of it or look at it or follow along, do whatever, use it for their own games if they want. But I wouldn't be accepting any code into the engine. I would want, so everything that goes into the engine would be developed here on stream. That was what I'm thinking for this. Yeah, but like Thin Matrix, he does that. He open source releases. Yeah, this guy does some cool stuff. And I looked at his. I'll post his Patreon. Yeah, you should check out at least his videos. He does some really good YouTube videos, which you can find over here. But yeah, I looked at his tiers and kind of based mine off of his for the most part. But I didn't want to commit to anything yet, so like I didn't say that you could get access to this source code here because I wasn't really sure how I would do that. With GitLab, it's possible. So someone asked earlier, why GitLab over GitHub? It's because GitHub doesn't allow you to do what I'm wanting to do, which is add people as collaborators and have it be, so have a private repository where I can add an unlimited amount of people as collaborators, but they have read only access. That's what I was wanting to do. For GitHub, it's like complicated, and maybe I could have done it if I like pinged them or something. But I was like, I'm just going to do it this other way. So that's why I decided to go with GitLab. Yeah, I was more thinking that people would be able to see your code, and if you were looking for collaborators, it may be easier since they could see your code and know how it works already. Oh, okay, yeah, that's true. Maybe have 2 separate licenses, one for engine and one for any assets and specialized code. The engine could be the regular MIT or this other standard open license, and the assets and specialized code is completely restrictive. Yeah, that's what I was thinking. That I could do. Originally, I didn't really think about that, and then as I was thinking more about it last night, like, yeah, so what we can do is, I wonder if there's a way, here, this is probably the easiest way, is to delete this, and then pull, and then it probably will prompt me to add in a license now. No, it just doesn't want. Oh, there it is. Yeah. And then we could just say, okay, we could do the MIT for this. Which is basically you can do whatever you want with it. Okay, so we'll do that. And so what I'm thinking I'll end up doing is probably having 2 completely separate repositories, and I'm not sure how I want to. What I might end up doing is having, yeah, I'll have to think about that some. I'm not sure how I want to set it up here. I'd probably have a separate, so I would have this solution with projectDIG or something that would have another Visual Studio project that I would link into projectDIG or something. I don't know how I want to do it like that. Yeah, I'm not sure exactly how I want to do this. Maybe what it would be is that I have in my other repository a solution that contains the engine, and maybe that would be it. It would just contain the engine. Yeah, I'm not sure. I don't know how I want to do it yet. Does GitLab work with source tree? Yeah, it does. Like, I got it set up here. It doesn't have like any special, like, you can't sign in to your GitLab, but you can just do SSH through it. It seems like it should work fine. Okay, so that's what we'll do then. So we're just going to, I don't know if I can like easily, I guess I'll just do this later. Yeah, we'll, I'll make it so that those, I don't edit page. I don't know how to do this. Ah, there we go. Yeah, so the robot tier will get access to the source code. And now I'm trying, yeah. I'll just do it later. So yeah, that'll be cool. So we'll I think it's like pretty much official. We'll do open source for the engine. For now, it will be locked behind the reward. I might Yeah, I don't know. I'm definitely looking for feedback on that. Like, if you guys think that that price is too high, I can definitely consider changing it or something. Yeah. Looking for feedback on pretty much everything always. But yeah, we'll do open source for the engine. And we'll try to put as much of the game's code into the engine. So it'll be kind of like Haley, which is another great repository that is worth checking out. Yeah, and they've kind of done the same, and I might actually reach out to them and see what they're doing. So yeah, cool stuff. Excited to share the source. I know a lot of people asked about that for Korea, and I just always told them no, that's not happening. But I didn't really know how, and also the code was just very mingled. And I think actually this entity component system is going to lend itself very well to that, where I can just have that stuff be separate. And it's going to work out. $16 a month for quick start to a game engine. Yeah, that's not too bad. I mean, that's cheaper than Unity, but I think so. Yeah, I don't know. I mean, it's also, I would hope that people are mostly doing it to support, well, I guess it's both. Like, yeah. It's pretty much the same as Handmade Hero. What I probably would also do is, and maybe I'll add this in, is that, you know, hey, you, yeah, I'll probably make it so that anyone who's at $4 or more will end up getting access to, like, maybe it would be like monthly release of the game or something like that. I don't want to have it be too frequent, but maybe like a monthly release of the game in its like alpha and beta state. And then maybe at like $16, I would just say, hey, you'll get a copy of the game whenever it releases, and so it'd be kind of like both things. Yeah. I was thinking about making so you get a copy of Korea every month. It'd be like flooded with Korea copies if you just stayed at that tier for a while. Yeah. Yeah, I think I'll probably do that. Right now it doesn't make sense. Maybe yeah, I don't know. Like, the first, like, few months. There won't be anything to release. But anyways, let's actually get to development. We've been talking for the last 20 plus minutes. So, short of it all, we're open sourcing the the projectDIG engine. Maybe in the future I would make under a much more restrictive license the game, like more gameplay specific stuff released somehow. I'm not sure about that. We'll figure it out later. And I have a Patreon that you can support me through. And that's how you can gain access to it. But anyways, so let's do physics stuff. So physics. Let me close a bunch of this stuff. Close all but this. It's such a nice little command. Okay, so what we want to do with our physics, we'll do a quick recap of that. Never ending story. What? The song? I've had this song stuck in my head for like 2 or 3 days now. From like, yeah, I think it was like this anthem or something. It's like do 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 do, and it was like from like 2000, and I can't remember the name of the song or the lyrics. But it's just that like it's stuck in my head. I think it was called like something along the lines of like anthem, or I forget. I haven't looked it up, but it was something that I listened to a lot. 20 years ago. Okay, so physics stuff. I bet there's apps that can tell you. Well, it probably needs more than that. Anyways. Physics. So we wrote out some stuff about how we want the physics to work in projectDIG. So we're doing a really simple physics system for projectDIG. So yeah, like I guess that's one thing that sucks about the engine, is that like you're going to get what I need. The pattern is using Never Ending Story theme. Oh, is it? Bittersweet Symphony. Yes, that sounds right. Yes. Yeah, that's right. The Verve. Good job. Yeah, 97. Yes. Winner, winner. Good job. Bittersweet Symphony, yeah. I don't know why I've had that little snippet in my head for a few days now. Back whenever it first came, I listened to that song a lot, which really dates me. 97. Well, I probably listened to it more a few years later, like 99 or something. Anyways, so here are some requirements that we want for physics. Players and items are only moving entities in the game, and maybe monsters or animals. So we don't have a ton of like moving stuff in the game. Items collide with each other, but not with the players. So that's something we want. At least I want to experiment with that. I might end up deciding not to have items collide with each other, but I want to play around with that. Players do not collide with one another, so you can take up the same space as someone else. Some entities will have collision, but no physics, such as tables, doors, conveyor belts. So they themselves aren't moving around in the world. So they have. So I'm kind of thinking of breaking it up into two parts. There's collision, which is kind of like, hey, I take up this physical space, and I will, there will be different layers, and only one thing can occupy that space in a specific layer. And then there's the physics, which is like actually mostly it's like movement and dealing with that. So moving entities around in the world due to forces, and well, gravity is just another force. And I guess displacement from collision. And I also want to have it so that one-way platforms, well, we can have one-way platforms and you can drop through them. So that's, I guess, really a collision thing, if we think about it. It's just like, we want some static layered collisions to support like you falling through it. Another thing actually that I should write down that I want to play around with is the idea of having moving platforms. So you can have like an escalator, or not an escalator, an elevator that can like move up and down a shaft or something. And that means that if someone is standing on this moving platform, then they need to move with it. Yeah. I don't think that will be too hard to do. It's kind of a special case. So we started working on this yesterday with this like division of physics and collision. So I came up with this idea where we have, what I'm thinking of doing is having a bounds for the collision. This is how much space it occupies. I don't know if we absolutely need that. I'm thinking of using it. We might not end up needing it though. We might be able to get away with using the bounds from the transform component. Maybe. I'm not sure about that. And so the bounds would be based off of the transform component. So it'd be something along the lines of, hey, let's update the collision bounds based off of the bounds of the transform component, or the X and Y. So it'd be like, this would be relative, so, you know, and actually that's really, I'm not sure how that would work the best. What we might do is like, this would be static, so you could say like, oh, this is, well, I'm not sure how we'd want it to be. If it's like based, we might want to always say it's based off of the center. So you could say that the bounds is like -5, 10, 10. So that'd be a 10 by 10. Oh, sorry. Yeah, 10 by 10 around the center. Maybe we would do it like that. And then we store the result. We take the bounds X and Y and add the transform X and Y to it to get the final position. Although that's a little complicated if our bounds, like that's right now in the top left, so maybe this would need to be in the top left. I don't know. I'll have to think about that, how that would work. But yeah, then we have the directions that there's collision. So depending on the angle that you're coming in, that supports the one-way platform. So you could just say, oh yeah, it only has collision on the top. And then we have this idea of which layer the collision component is on, and then which layers it collides with. So we could have, like, there's a static layer that all entities would be colliding with, most likely. And that would be stuff like tables and doors. And then we would have the item collision layer, which is specifically for items, and so items can collide with themselves. So we would have an item that would be on the, or items would be on the item layer, and they would collide with the static and the item layer. And then the player would be on the dynamic layer, and it would only collide with the static layer, so players don't collide with themselves. So I think this is powerful enough that we could do whatever we want with it. And so we might need to support some other things within here, namely like the one-way platforms. We might need to think about like how we would do that in here. I'm not sure yet. But that's it. And then we have our physics, which is velocity, force, mass, gravity, scale, and restitution. Mass is something new that I didn't do in Korea. I think it will be good. We'll play around with it, see how it works. Yeah. Oh my gosh. Look at this. Ad block has blocked 6,283 ads on this page. Ad block. Doing its work. Yeah. Well, that's a lot of ads. That is a lot of ads. It's because I've had the page open and it seems like it just keeps trying to like change or load up new ads every few minutes. Yeah, GameDev.net. I used to actually frequent this website a lot back in the day. Yeah. So math, yes. Hey Mundo, what's up? We're doing physics. Physics is definitely math. So I was looking at this website or this like blog tutorial thing. It has some stuff about collision and whatnot. We might use some of it. I'm not sure exactly what. What's probably the most useful is stuff like resolving the collision. I did my own thing for Korea and I didn't like how it turned out. So I was kind of wanting to do something like maybe looking at other solutions. So here's what I got for Korea. Oh, I have it over here. So this is the Korea game engine, which is my previous game. And what it does is right over here, it does collision. So we resolve the X first and then the Y. We separate on X and then separate on Y. And then we also handle passing through, which is going through one-way platforms. Hey David, what's up? So separating. This is so first we figure out if we have any collision, and so the physics collision, which is basically what he calls the manifold, is over here. It's just the component that we're colliding with, the slope. If it's the slope, and then if it should collide or not. Don't know what that is exactly for. I guess it's just saying if we have any collision whatsoever. I guess. Oh, that's I think that's for sloping to differentiate the two. Yeah, so I'm not going to do slopes for projectDIG. I don't think so. I don't think so. What do you think about Java as an Android Studio? Is it any good for a beginner? I don't know what that is. And so I don't really have an opinion. Do what works best for you. I typically recommend Python or something like that, but what's most important, I think, is just doing something and not worrying too much about like what you are learning. You can, once you learn the basics of programming, you can pick up other languages fairly easily. What I would recommend is searching for interactive courses online, such as Codecademy. And I'd probably recommend C# over Java. C# is a much more popular language right now, and it's, in my opinion, more pleasant to work with. But that's just my opinion. So yeah, I would search for like C# interactive language courses, or even Python is good. Mundo asks, have I considered using a game engine? If I understand, you are making your own. Yes, I am making my own. I did consider it, but I know exactly what I want to do. I made a game engine before. This is it, the previous game engine. And so I have experience doing engine development. I wanted to make this be a community project, so I figured making my own would be a good way to do that. And then also, I think that development will end up being faster doing my own engine rather than using an existing one, because I know exactly what I'm wanting to do, and I'm not doing something that lends itself super well to existing engines. So I'd have to do a bunch of customization. Like I have to do my own physics, because I want physics to be set up a very, very specific way. Maybe with Unity I could finagle it to work well, but I also want to do like cellular automata and a bunch of other game systems that are unique to this game that aren't in other games. So I'd have to do all that anyways, and I kind of just prefer to do my own thing. I don't know. It's just what I'm used to. I've been coding in C++ for over a year, but it varies simplified in Arduino electronics. Oh, cool. Nice. I've looked at Arduino some. Arduinos. I think that's how you say it. I've kind of wanted to play around with those, but can't actually come up with a good reason to. JavaScript works too. Like I said, mostly just doing something. Sounds like you already have some experience. Yeah, I like C#. If you've already done C++, C# is good. If you want to do JavaScript, I don't know what your end goals are, and that definitely would dictate what would be the best course of action. But I think doing anything is better than nothing. So there's that. JavaScript is definitely used in a lot of places. I'd say right now probably some of the three most commonly used languages that I know of, this is mostly in games, is like C#, C++, and then maybe Lua and JavaScript probably as scripting languages. C# is like by far the most common now, thanks to Unity. Anyways, so we're separating on these different axes, and this is what my separation logic looks like. It's not very good, but it is something. But I think that one of these, like what this guy is doing, is probably going to be a lot better. So we have actually, where was it at? It was up here, right? AABB versus AABB, which is axis aligned bounding box. This is actually pretty much what I'm doing now that I look at it. We get the world body, which is the bounding box. Calculate half extent along x-axis for each object. Half extents. I don't think I do that. I don't do that. What I do is I get the delta of these. I'm not sure why I do that. Might be that I'm doing some weird like order of operations. So I get the previous position. So I'm saying, hey, how much did this move? I'm not sure why I do this. Delta 1, delta 2. And then I get the body rect. Check if the bodies are ever overlapped or are currently. Yeah, okay, so I guess this is a little bit different. Calculate the overlap. That's what this is. This intersects. There's the max overlap. Which axis is overlapped of least penetration? Move towards B, knowing that N points from A to B. So it figures out the normal. So that's nice. Can also look at what they do over here. This is in box 2D. Solve velocity constraints. This box 2D is much more complex though. Much more complex. Because it's handling like all of the possible things. Swept collisions. Hey Code Slasher, what's up? Are the boxes going to rotate? No, I'm going to keep things very simple. So there's no angular velocity whatsoever. Yeah, I don't want to do that. I mean, that's just for collision. I guess that's getting away from what I was really wanting to do. What I really want is the resolving separating axis theorem. Is that what this? I guess that's what this is, huh? Right here. I didn't actually know what SAT was referring to exactly, but that's it. Separating axis theorem. I don't want a video. I should read more about this. Vector math. Yeah, we don't need the rotation. Because you're not supporting rotation, it will be simpler, right? Yeah, I don't know if I even need, like, this is assuming that it can rotate. Honestly, I think something like this, wait, this right here, would probably be sufficient. Yeah, the axes, we're just doing X and Y, that's right. So we're only doing axis aligned bounding boxes. And not worrying, we're not even going to do circles. We're just keeping it brain dead simple because while this game is going to use a lot of physics, it's not a physics-based game. And so we don't need like crazy physics simulations or anything like that. We just... SAT is so easy to build, but if you're doing AAVB only, don't bother. Yeah, I don't think we need it. Like, I considered going down that route for the game design, where you could have, like, crazy physics, you know, items bouncing around and doing stuff. But I really think that would start moving more in the direction of... Like, I could see that being a game, and I think it would be kind of a cool game. So if you guys want to build this, a factory-based game, or like a automation type of game that's physics-based. So like Infinifactory mixed with like Armadillo Run. And they kind of have that in this game called what was that game? The Portal game. I talked about this a while ago. Portal, yeah, Bridge Constructor Portal. But this game is like really simple. It doesn't quite do what I'm talking about. But I think it'd be cool. A game with like conveyor belts and stuff like pistons and whatnot. So kind of like this game with Infinifactory. Infinifactory is like this, but it doesn't have any physics whatsoever. There's just pistons moving stuff around, conveyor belts. And then Armadillo Run, which isn't on here, but it's a physics-based game where you can set up a bunch of objects and the physics interacts in crazy ways, and you're trying to get the armadillo to a destination. But yeah, I think that's like one game, but I'm not building that game. I decided against that, and so I want to focus on other stuff, and so I think that having really basic physics is okay. Like, Kyle, doesn't Vagante only have like really basic like AABB physics? That's what I could tell. Like, I know that the entities that move around in the world have collision, but it looks like everything is really simple. I did notice that you can kind of like slide off of monsters, right? Maybe, so like maybe there's circles. Convex holes later on for weapons. Oh, okay. Gotcha. Which weapons need the convex holes? Yeah, one cool thing with this system is if we ever wanted to do something like that, like add in convex holes or whatever, we could just make a new component for that and a new system that would handle that collision. I think it would work. Oh, okay, gotcha. I see. Dang, nice. I would have never guessed that. That's cool. That's cool. Okay, so yeah, we're probably going to want to do something like this for our collision. So, I don't know how I want to do this exactly. I was like thinking, oh, I can add in an apply force function. But do we really need to do something like that? Like, I guess I need to think about how this is all going to work out. Gravity scale. Yeah. I imagine. Replacing old code is always a pain. Well, not always, but for like more fundamental systems such as that one, I could definitely see it being a lot of work. Yeah. Excuse me. So I think we need to kind of sketch out how this is going to all work. Maybe we'll go to our physics. So what's like the order of operations that we're going to need here for this? Maybe I won't do it here. Let's do it in like over if time right now expired. Yeah, we could do it like just over in here. So physics. So we need to obviously have collision. I think first we need to move everything, right? So like maybe apply gravity would be one thing that would happen. Like that could be its own thing, possibly. I don't know why I did it like that. Which is really a force. And then maybe we need to like... So I don't even know if we need... So what's the difference between having... And so this is... I'm trying to... think about how we can do it differently from what I did for Kriya. So in Kriya, I just had it so that your force was applied to your velocity. Or actually, whenever you apply a force, it just affects your velocity. Which I don't think is how it's supposed to work. Whenever you apply a force, it's supposed to be based off of the mass of the entity. Or, sorry, that physics thing. Physics component. So, Kriya didn't have any concept of mass. So, whenever we would apply a force, it would just add that force to the velocity. I don't think that's right. I think at least there's the part... And so maybe we do need a apply force function. I wonder if I should... Like, maybe I could put it in here. Whoops. Like, we could just have, like, some functions, like, apply force. And it takes a physics component and the force that you want to apply. And it will figure out, you know, I'll add that. Or actually, wait. Do I have a force in here? I guess that doesn't make sense. We probably don't need force, huh? I don't think we need that. That doesn't make sense. We'll have like our velocity and we'll say, okay, well, we'll add the force times, and we actually don't have a way to do this, so we have to do it in 2 steps. Times the physics mass, something like that. It actually, I believe, needs to be the inverse mass, if I recall correctly, that we want to do it to. So that way, like, yeah, we need the inverse mass here. Yes. Yeah, I think I actually read that typically we just want the inverse mass because that's what you always use. And so whenever we are setting up an entity, we will say allows for mass of 0 for non-moving objects. Yeah, although typically I think a non-moving object would just not have a physics component at all. Hey, Tenwei. Should I learn C or C++? Whatever. It depends on what you prefer. Is the collision component separate then? Yes. That's what I'm thinking of doing. That might end up not being the case, but right now I'm thinking so. This is what our collision component looks like at the moment. Just because I'm thinking that some things will have collision and some things will have physics, and they're not necessarily overlapping. Like, the player will have a physics, but they won't have any... Or actually, they will have collision, right? I guess it's that some things will have physics and collision, and some things will only have collision. I think that's what we're thinking of. So the inverse mass is really just 1 divided by the mass. And so we'll end up calculating that later when we're like setting up the component. So like, or the prefab stuff. So if we go to like here, let's see here, physics. You know, we're setting up a physics component where we're like, oh, the mass is this. Well, now it's called inverse mass. You know what? I should do this. Oh, come on. Okay, rename it to inverse mass. And so what it really should do is be like, oh, this mass is 5, whatever that means. And, well, we would say that the mass is 5. I think it would be like inside of the Lua file or whatever. We would say, oh yeah, the physics is 5, or the physics mass is 5. And then inside, when we're actually setting it up, it would be, oops, something more like this. You might have physics and no collision too, like maybe a hologram of a shooting cube. Maybe. I don't know about that, but maybe. Yeah, we'll see. I think we'll figure it out once we actually have the system in place. We'll see what makes the most sense. So yeah, that's our what we'll want. I think that is all right. So in velocity, inverse mass, gravity scale, and restitution. So whenever we apply gravity, it's just going to be the gravity is applied as a force times the gravity scale, right? Actually, that's not quite right, because isn't I don't know about that. Because that would make it so that smaller things would fall faster, so that's wrong. I think that's wrong. So what else do we need here? Let's go back to the, whoops, sorry, this. So we have apply, so yeah, gravity is kind of a force. So this apply force function would be a helper function that would just be kind of by its own. So we could pass in a physics component and say, hey, apply this force to this. I guess really that's kind of it, huh? Most of it's, almost all the physics is just dealing with collision. I guess there's also restitution. I think restitution happens afterwards though. So this would be like resolve collision. So am I missing something here? There's friction that probably happens in result to the collision, right? I think this guy talks about that in here, yeah. Friction is something I definitely did not do right for Korea. So whenever you do restitution, does he do it in here? Restitution. Oh, impulse oh, no. Impulse resolution, is that basically the restitution? I guess so. Penetration depth. Yeah, okay. So it says get the restitution, the minimum of the two objects. That's something I did not do in Korea. Is like the ground doesn't have restitution, and that'd be kind of cool to add in. Is like, maybe dirt will bounce. Has dirt would have a much lower restitution than like wood. Obviously, like wood has a really high restitution. Or soils would have lower restitution. Metals would have kind of a higher restitution. Oh yeah, rubber would have a higher. Well, I guess it kind of depends on like how tight it is, but yeah, I think rubber would have a pretty high restitution. Like if you stretch out rubber and then throw something against it, it would bounce pretty high. Why do you use the inverse mass and not just divide the force and the mass? Yeah, division is almost always slower. Well, it is slower than multiplication. And I read from a few different sources that you pretty much only ever need the inverse mass. So you would always be dividing by it. And so it's like, well, you might as well just do that division up front, store that inverse mass, and then never use the actual mass. So that's something I'd like to do is using the minimum of the restitution. So we could have the ground have different restitutions. Which actually brings up a really good point, which is that kind of means that things that have collision should have the restitution. So maybe what we should do is move restitution over to the collision, huh? I think that makes sense. We'll put this up here. Those are all unit aids. Yeah, no problem, Zargo. Yeah, it's whenever you're looking at any code or anything, you want to look at like how is it being used. If you're doing the same thing over and over again, then you might, that might be a good opportunity to try to, cache that, store that somewhere, so you only have to do it once, and that's the case for this inverse mass, and it can be the case for many things where you just like, hey, I keep doing the same thing over and over and over again. Let's sort of optimize that a little. So we can have the restitution on the collision. I think that makes a lot more sense. See, like here you can see that this complicated function ends up being the inverse mass. Resolve collision. Okay, so this is the restitution, what he calls the impulse, is after the collision. It applies an impulse, where J is time multiplied by the normal. Calculate impulse scalar. This is stuff I did not do whatsoever. So that would be, so this is like before it actually, I see. Interesting. So what do you use this for? Like, why do you need this manifold? What is it doing exactly? So this is telling us what? Return true, return true. This code is not the best. For one, he doesn't return false. I'm guessing it returns false if it doesn't hit one of these two. Which means that... Oh wait, it always returns... Oh wait, only... If it has no X overlap, then it's not going to have any Y overlap. This has to be wrong though, right? This code has to be wrong. Like, what if you have a sticky pad and at any speed could you make it not bounce? Well, you just set the restitution on that sticky pad to be like 0. And here it says, so he actually talks about it more up here, that coefficient of restitution. Restitution is a term that means elasticity or bounciness. Each object in your physics engine will have a restitution represented as a decimal value. However, only one decimal value will be used during the impulse calculation. To decide which restitution to use, denoted by E for epsilon, you should always use the lowest restitution involved in the collision for intuitive results. And so basically it's just the min. So if you say, oh yeah, the sticky pad has 0 or 0.001 or whatever, then it'll like maybe be able to bounce just a tiny bit. So even if you have a bouncy ball that has like 1 restitution, or if you want to be crazy, 2, which I don't think is really possible, this thing will bounce at twice the height that it, or twice the velocity that it impacted. That's 1 bouncy ball. So yeah, that will handle that case. So if you have like a carpet or something that has very low restitution, you could set at like 0.1 or something. And so that's what I was kind of thinking maybe we could do with the different soils. So whenever something hits the tile, we would check, like, I'm thinking, so tiles won't actually have their own collision. They will be kind of separate from this whole system, but we'll be using it to some degree. Like maybe we'll create a manifold or, I don't know, do something with it. And look up what is the restitution for that tile that the object hit, and then use that in the equation. So it seems like we actually want to I'm not sure about that. This is the one thing I'm not sure about actually. Is like how do we want this to all be ordered? I'm just kind of looking at what this guy does to get ideas. I should also look at box 2D. Like I don't know the order of operations for, like, should we first be resolving the collision and trying to separate the bounding boxes and then apply the restitution and friction. So the friction and restitution are somewhat at odds with one another. Kind of. I mean, you're taking the normal, right? The friction impulse. I think you have to take the normal while doing, the tangent. Yeah. That's right. We calculate relative velocity after normal impulse is applied. So I guess what he does is he does friction after the restitution. So it's like the collision, impulse, restitution, and then friction. So I'm just not sure about that resolving the collision. He kind of talks about, I guess they don't really do that much, huh? Like the overlap and this penetration. So what does this code actually do? Which axis is axis of least penetration? This, yeah, okay. So it creates this manifold. I don't really get that. So what Kriya did is it would actually separate it immediately, and I'm like wondering if that's really the best way to do that. Oh, whoops, wrong source code. So here, what I would do, let's see, get overlapping, overlap. Where was it that it would actually separate? Intersects, max overlap. Get the overlap. Yeah, okay, here it is. It would determine the overlap, and then it would actually separate the objects based off of their, like if they're movable or not. So if like they're both movable, it would actually separate them this way. This is why if like I ever made it so that, let's say, an item could collide with the player, then what would happen is if you jump on that item, it would keep trying, gravity would be pulling you down and be pulling you into the item, and then it would try to resolve that, and it would say, oh, okay, well, we need to now like push the player out of the item, but it would like end up like pushing the item down into the ground because the item was technically movable, and it would just like sink into the ground as you stand on it, which is definitely not right. I think the problem with that is because we would do this after it would resolve some of the other stuff or something. Like really what it should have probably done here, I don't know if that makes sense, is like check to see if the item can actually move downwards or something. I don't know if that would be right. Yeah, how would we handle something like that? Like, let's say that we have two items stacked on top of each other. Or an item on the ground and then another item falls on top of it. We would need to like displace them. Not sure of the best way to do something like that. Alright, so there's the restitution that would hit it. And then that would apply, I guess that applies the, well, it's not really the restitution, it's the impulse, right? And so that's what this would be. And so that actually is where it applies the impulse to both of them. Yeah. And so it should actually technically hit the other item, and the other item that's on the bottom should hit the ground and maybe bounce up a little bit, and the item that hit the top should bounce up even higher because it had a greater velocity, right? Yeah. Ooh. Hey, Cooler, what's up? How's it going? I think this is right. I'm just not sure about the actual collision part and like whenever the items come to rest specifically. Because one item would be pulling down, like we'd have two items that would be wanting to be pulled down by gravity. But then there's, you know, the the ground that's static, and so they won't be pushed into the ground. Neck crack. Yeah. Feels so good. Yeah. I think this is okay. We'll just have to figure out the separation part. Thinking about that a little bit more. What's this positional correction? This is performed after the impulse is applied. Positional correction is very simple. Move each object along the collision normal by a percentage of the penetration depth. Yeah, I guess our objects would have infinite mass. Our ground would. Okay, this is exactly what I was talking about. The problem of sinking objects arises when something starts sinking into another object due to gravity. During each floating point calculate. Yeah. I see. Okay. So this is the solution is after we resolve. I guess it's after the restitution too, right? We want to do that. Yeah. I don't really get where this logic goes into place, but like what this is used for. What is this manifold used for? Do you guys know? Yeah, I don't care about the time stepping stuff. Materials. What's this doc I'm looking at? It's this here. Manifold, it's used for the collision resolution. Yeah, okay. So I guess that is really just what I did here for Kriya with oops. With this, I have this physics collision, which contains, it doesn't contain a ton, but it contains a little bit of information. Yeah, I think that maybe part of the reason is that this code is a little wrong. I'm almost positive it's wrong. Does it make sense to, because there's no check on the y-axis if the x-axis has no overlap, right? Yeah. X is greater than 0. Yeah, in box 2D, that is the manifold is the fixture, right? I think that's right. Or maybe it's the contact. I don't remember. Mix restitution. Oh, here's the build manifold. Okay, they do have a manifold. Oh, I see. Do not modify the manifold unless you understand the internals of box 2D. I see. Yeah, we're not going to worry about bullet physics though. Okay, so it seems like this is pretty much what we want to do. Maybe we need to build the manifold at this point for the physics collision. I'm not sure about that. Yeah, I'm still piecing together that one part of code. Like, really, like, how does this work, or how do we want to handle this? So as the penetration, what does he specify what he's doing with his manifold? Penetration and normal. So the normal is the angle that they come in contact. Whenever you're working with ABB, it's really simple. It's either they're coming in at one of the sides, right? Isn't this wrong? Isn't it supposed to be 1 here? Pretty sure this is wrong. This code has a lot of issues with it. We'll definitely not be copying it. Yeah, except for mine. All physics engines are the same except for mine, which is, or for Korea, which was I mean, it's kind of similar, but it's pretty bad as well, I think. I think I did some things that is not quite necessary. Good tiles on the right side. So I did this. One thing I'm not sure about is that I have it so that the tile collision is all handled here. I'm not sure about that. Where is it at? It's not quite there. Add touching. Oh, I think it's up. Do tile collision. Wait, where's that called? There it is. So if the component has ground collision, then it'll collide with tiles. And what that does is it actually like looks at the ground and checks to see if you're overlapping stuff. So this is where I probably would want to do a completely different system. That's what I'm kind of thinking we might want to do, is something along the lines of like resolve collisions between physics, or not really resolve, but it's like, you know, build collisions between like physics, or build collisions what makes sense for physics with yeah, I guess it would be build collisions with entities, with other entities, collision manifolds, I don't know, whatever. And then we would have it build collision manifolds with the ground. We might want to do it the other way. I guess it doesn't matter actually. And then we want to resolve collisions using the manifold. So these would be separate. And honestly, they might be, like, this is something that we could potentially parallelize, where like they could simultaneously be building the manifolds for collision or with the ground and other entities. And then we would resolve our collisions. And so this would be our, in that case, our collisions would be stored in some, like, you know, world. It would be a world component, and maybe it would be like, physics, manifolds, or manifolds, I don't know, which is a component, and it would just have a list of manifolds in it. And yeah, so that's kind of what I'm thinking we could do. And so then with the ground, this would be like the ground where it's like, oh, let's see what tiles it's overlapping. Let's figure out the for this. He doesn't have this whatsoever. Penetration. This is one thing I'm not sure, like, how is he using this manifold? Seems like there's a lot of problems with that code. People are complaining about it. This code doesn't make sense. This whole manifold thing. Maybe I need to find a better example of how that's supposed to work. But what I'm thinking is that our manifold, I guess if we store a pointer to the collision component or something, or maybe we might not want to do that, honestly. We might want to copy, like, we can determine the restitution for that collision, the manifold, at that point, right? For the two objects. Oh, I guess that's true, is that we need the objects. Yeah, so what we could maybe do... We could potentially have a collision component that corresponds to the tiles. I could see that. So our manifold would look... I don't know where. Let's just put in the physics header for now. Yeah, I don't think we would want to put it in the namespace. I think we want to keep the namespace pure, just to that stuff. So it might be, actually it'd probably just be a struct manifold. And what we could do is have a collision component. The two collision components, and if you collide with the ground, then it just uses the ground collision, possibly. No, that doesn't work because we need the velocity to apply. That's right. That doesn't quite work. We need information from both of those, right? Well, actually, what we could do If we have the collision component, we only need the restitution from the... Oh wait, no, we would need the bounds as well. Ugh. I guess we could copy over that stuff. We don't need this. We definitely don't need those once we have done that. Maybe what we could do is something more like this. Physics component. And then we could have like the bounds 1 and bounds 2, perhaps. And then our restitution. And so we could calculate the restitution. We can just get them in, and so we can only store that store one of them. We don't need both. Maybe that would work for our manifold. And so then we can actually be able to modify the velocity. Because whenever we at some point will want to do a write to the physics components that this is storing. I don't know if I like this, honestly. I guess it would be more efficient than going to our system and doing a hash lookup of that. Like, the other way to do this would be to say entity physics 1. Hey, Blands. Yes, things are going well. How about yourself? Welcome. But then we're gonna have to do like a world lookup. We'd have to do world get physics component physics 1, or maybe we want to do entity 1 really. So then we could store that and say, well, this is our physics component. Like, this is doing an extra hash lookup, and yeah, it's just doing more work. We'll have to think about this. I think that this would be better. The one thing I don't like about this is that then it's kind of not completely obvious that we're manipulating the physics component with this manifold. Like, we have access to this component, and we're storing this component outside of the world, and I kind of don't like that. But it's definitely inefficient to do it this way when we can already have access to it. So I don't know. I'll have to think about that. If we're willing to do that. But this is what I think our manifold could look like. So we would have a world component, physics spatial component. I don't know if this is actually going to be necessary. The fewer special cases, the better. Sorry, what are you referring to? I imagine this, but what do you mean by that? The fewer special cases. So yeah, I think we probably won't need the spatial component, maybe. So you would consider the manifold holding direct references to be a special case, or no? I'll do the other approach for, okay, so you would do the entity like this. I see. Yeah. Yeah, you're probably right. Like, yeah. I guess what we could do is see how it deals with performance. It's definitely going to be a hit because now we're doing an extra cache lookup. The nice thing about this is, as I said, then it's very obvious. Like, we don't have access to any external data in the manifold. And it's very clear, like, if we want to change the state of anything, we need to be requesting that data, you know, getting the component and iterating over it. Yeah. We'll be processing all the manifolds at once, but yeah, it will still, I don't know, we'll see how that works out. Cache miss, yeah. We'll see how it is. Because instead of going directly to different, we'd be jumping around. If we're storing the pointer, we'd be jumping around in memory within that vector. But now what we're going to be doing is requesting from the world, hey, go look up the ID or the index for this entity within the, so there's like the extra lookup check, which maybe it doesn't really matter. And I agree, we probably should have this be better design initially, and then if it's truly a performance issue, we can worry about it then. Physics, manifold, I guess. Manifold component. Yeah, I don't know if we're going to do this. Let's comment this one out for now. Or actually, I'll just delete it. I think we might do the spatial hash within the system, and it would not be stored inside of a component. We'll see. So I actually need to make a new one here, which would be like physics manifold. So again, this is a world component, which means that it stores the manifolds for the system. So instead of the systems having state, we'll have this world component, and this will be pretty much how we communicate between the systems. So we'll have, I think what we're going to do is have a different system for each one of these, or at least like break it up into maybe a few parts. So we'll have like building the manifolds. This will probably be two systems. And there'll be, for now, we'll break them up and they'll be like one after the other. And the reason for doing that is because this will open up the possibility in the future for us to easily just say, okay, well now let's have these systems running on separate threads. And so we could say like, okay, now instead of doing like building the collision manifolds one after another, we just parallelize those systems. And then whenever they finish, we can then resolve the collisions. And that would, you know, be able to go do something else. And so this would depend on having these be finished. And then once this is done, we can, maybe resolving the collisions also does the restitution, positional correction, and applying the friction. So it might just be that we have maybe like 3 apply gravity force. I don't know about the gravity one, honestly. Could we do gravity afterwards? That should work, right? Or no? I think that would work. Well, we can always just try it out. Add that component in. Where am I creating this again? The world components? Did I set that up? Sneezing. Ah, fun times. I don't remember if I did or not. I don't think I did. I have my world components here. Does that get populated at all? It does. Okay, I have to manually set that up. Boo. Yeah, again, I would like to really figure out how to do this in a way that wouldn't require me to do that. This array isn't initialized to be empty, huh? Isn't that potentially a problem? Or is the array cleared? I don't think so. Don't I need to clear it? Like do something like that to say that it's... So that way the components are not initialized, so whenever I iterate over them, we're guaranteed that it'll be empty. I think I need to do that. Okay, so I do have that being set up. I just have to manually create it for now. I'd like to come up with a better way to do that. But anyways, so our physics manifold, this is kind of ugly because really what I want to do is have this be... Where would I want to store this? I don't think I want to include the physics header in here, but I'd like to have this just be a vector of physics manifolds, or manifolds. And yeah, we don't have access to that in there. How should that be set up? Yeah, this isn't the most simple piece of data, huh? It's the vector of a class. I could just put it in here. I don't know if I'd like that though. Does that make sense? Maybe it does. What do you guys think? Is this like an okay design where we put the manifold here? It kind of makes sense because we're always going to be using the manifold in the context of the physics manifold. Like they're kind of tied together. Like we'd always be placing a new manifold into this physics manifold. We'll probably actually use in place back for that when we're creating new ones. Yeah. So what we might do with this physics is have multiple, so we're gonna have multiple systems. So we're not just gonna have a physics system. So I'm thinking if we can, I'm going to try to apply the gravity afterwards. Hopefully that's okay. That might be a problem. I'm not sure about that. I think it's okay. So then what we could do is basically, we would say, well, this is a system, and then all of this would be done in the system. So this, yeah, and then these are systems. So let's see here. What would that make this stuff do? So that would mean that this, when we build the collision manifolds with the other entities, what we need to do is, well, actually, I take that back. I think maybe we do need to do this. I take that back. I think we need to have this. So it's not just applying the gravity force, but it's also applying the vector. So it'd be like, what would it be? Applying gravity force to, yeah, it'd be, apply, and actually I think this could be one thing. So we'd have 4. Apply velocity to position. So we'd have the velocity. So we apply the velocity force to our gravity. Oh, sorry, our gravity to our velocity. My bad. And then we want to apply the velocity to the position. So we say, okay, now here's the new location. So then that would mean that for this system, we would, maybe I should break this out into 2. We'll come up with a name, and these are like the stuff that we're doing with it. So maybe I'll do like this. Just trying to organize our physics system. Physics systems, I guess, is really, it's a group of systems. So this would be, I don't know, like, what is this called? Like apply velocity. I don't know what I want to call this. Physics movement, maybe? I'm not sure. So this would need to have read, or I guess I should say read-write, to both physics and our velocity is changing our position, which is our transform. So it's read-write to both our physics and our transform components. And it doesn't care about the velocity whatsoever. Or sorry, the collision. Oh, you know what? Do we... I guess for the ground we don't care about that. That's true. Okay, that's true. So just trying to think this stuff out. I was thinking, do we care about the spatial partitioning or creating a spatial hash when we're calculating the collision manifolds with the ground? And the answer is no, we don't care about that. So that's cool. Oh, whoops. Let's do it like this. So this we're going to call maybe physics collision. Physics entity manifolds. I don't know, something like that. We could be very verbose. Build physics entity manifolds or something. Which, does it care about the, does it care about our physics component? It definitely uses the world. It's going to be writing to the world, or wait, what am I calling it? Physics manifold. So it's writing to that. I think that's the only thing it should be writing to. And then it needs to read the physics. No, maybe only collision. Oh, that's true, is that we need to... I take that back. That's kind of gross. Maybe we actually need to... So we don't need velocity. Do we need inverse? Whenever we're building the manifolds, I think we do need to only have, yeah, there's the overlap. So we don't need the velocity. Yeah, I think we need to write this, but we also need to, at some point, we need to be updating the collision. Right? We could do that here. Oh, no. We need to do that earlier. Yeah. We need to update the collision bounding boxes, right? With the current transform. I think that might need to happen here, where we say update... and this maybe should be a separate system. I don't know if that makes sense. Exactly. Because it needs to happen at this specific point. Before we start building the manifolds and after we've updated the position. We need to update the collision bounds with the new transform position, right? Yeah, I wonder if we really need to do that. Oh wait, no, yeah, that's right. Let's not do that. Let's have it so that our manifold has the actual bounds. We're doing that already, actually. So we never change the collision bounds. The collision bounds should be pretty much read-only. And so like I was saying earlier, that's right. I was saying earlier, this will be relative. So it would be like -5, -5, 10. Or maybe it would be like for our items, which are currently 24 by 24. it'd be like this. If we wanted it to be from the center, maybe we don't. Maybe we want to say it's the top right. That would make it really easy to just add it. So we would just say, okay, well, when we're updating or whenever we're calculating the manifold, it will be something like the manifold bounds is equal to the transform x, y, oh whoops, my bad, plus the collision x, collision y, and then this is this collision width and height. So that's the bounds. Man, I got quiet in chat. What's up, guys? What's going on? Is this making sense? So yeah, we don't ever change the collision. So that's actually really good. I like that a lot. Hello. So we're writing to the physics manifold and we are reading the transform and the collision. Drawing, nice. Yeah. And then it's actually going to be the exact same in here, except we will need to read some like tile. I don't know. I don't know how we're going to handle the tile system, honestly. That one is complicated. I guess it would just be it's probably going to be reading some like world tile component or something like that, which contains all of the tile data, I guess. I don't know how we want to do that yet. I haven't thought about it. Fortunately, we don't have to figure it out right now. But that's kind of what we want. I'm thinking this would be like world manifolds, which is pretty much tiles. So we would need to read that. We're not modifying it whatsoever. We're just building the bounding boxes off of it. Oh, that's actually a good question. Is like, I guess that works. With the manifold, maybe what we could do is, I don't know if that's a possibility. I don't have a null entity right now. I guess we could maybe do something where we would have a manifold with only one component or one entity. So what if, you know, we have this item that's falling and it hits. Yeah. Let's say we have an item or the player hits the ground, right? And we want to create a manifold off of that. We don't ever need to get the physics component for that. So our manifold, like entity 2 could just be, you know, basically a null pointer, except for it's an ID. But I don't have a concept of a null entity ID right now. I probably need to make one. I guess what I could do is like, you know, there's definitely the possibility for me to do that, right? Like maybe where these are all capped, where it's just like max uint 32 could be the invalid entity ID. And that would always be the case as long as type would not possibly be a valid number. Or another possibility, actually, maybe that would work, is what if 0 is, no, because I want the problem is that I use all of this stuff, all of these as indices, like the ID, the generation, the index, and the type. They're all index 0. I guess I could just do that with the prefab and just put an empty prefab at type 0, or I mean at index 0. So it's like prefab ID 0 could also be null pointer or whatever, or it could be invalid. Hey David, awesome, nice. I hope that goes well. Python's a fun language to learn. It's very useful for doing small little tasks. So yeah, I think that could work. So we could say like an invalid, like a null entity is just 0. Which means generation 0, index 0, and type 0. And typically generation and index can both be 0, but we would say that type can't be 0. And then I think that would work. And so then we could, in here, for entity 2, entity 2 could sometimes be 0. Or invalid. And so whenever we're building the world manifold, that would actually always be the case, is that our entity 2 would be null. And so whenever we go to resolve the collisions, that's when we let me do that. Physics collision resolve. I was like, wait, resolution. I was wanting to write resolve. This writes to probably many things. Right, apply friction. So it's definitely writing to the physics. It's definitely writing to physics. And it only needs to read the physics manifold. Is that it? Transform. So this would, we don't need to mess with the transform here, right? Or do we? Do we need to resolve and move the entity? Because otherwise it would be one frame, it would be stuck inside, right? So we might need to write to the... This feels weird though, right? To have to be doing that twice. I guess it's... That's probably right though. Because otherwise we'd have the case where, like, let's say two items collide, we'd have a frame where they would be overlapping and then they would separate. You know, if we didn't update the transform in this step. You miss semicolons and having to define int and float. Yeah, static typing is definitely useful. That's what it's called. So the static typing, which is like C++, C#, C, etc. Compiled languages typically. And then there's dynamic casting, which is what Python and Lua have, and other scripting languages typically. But there's definitely a line being blurred where, like, in C++ you can use auto now, or I think in C# it's var. where you're just like, oh yeah, this is a variable and you figure out what this type is. It does determine the type, so it is still statically typed, it's just that you don't have to specify it. The compiler figures it out based off of how you are using it. So yeah, I think that this is how we want to do it. So it's reading the manifold and pliers. I think this is all good. So I think that's what our physics systems, plural, will be like. I think it all makes sense now. So we have to actually start writing code. No! Auto was a side effect of the nightmare that became writing templates. Yeah. It is a nightmare to try to get that. You're like, there's this thing, like, that's where you would just be using type defs all the time. Trying to cut down as much as you can on the amount of, like, code you have to write to define a type. Okay, awesome. So we have this all figured out. I'm going to take a, like, 2-minute break or so, 3 minutes, and go kind of start prepping my lunch so that way I can actually eat some food at lunchtime. So I'll be back. Going to cook a yam, tasty yam, and then we'll start coding. Be right back. Okay, I'm back. Sorry, that was more than 3 minutes. Decided to get some water and go to the bathroom really quick as well. But yeah, okay, so what we have so far is our systems and how we want them to be operating. So that's good. I think this will work. So we're not going to do this one yet. We'll do it in the future. So thinking here, what we'll do, I think what we're going to do. So we're going to be changing our current physics system. Yeah. So I want to use these names. So we have like physics movement system, maybe physics build entity. Yeah, probably all prefixed with physics. So it should be more like that. I think I might get rid of the build. So it'd just be, I guess in that case it'd be this. Physics entity manifolds, physics world manifolds, physics collision resolution. Yeah. So we would have these different namespaces. So it'd be like physics movement system. It's so long. Maybe we can just do physics movement. Yeah, maybe we'll do it like that. Namespace. So these are all going to be the same, right? Like, I could do. This is what I love about multi-select, is this stuff like this. Could say, well, let's put, oh, whoops. Wrong thing. Space that out, lowercase it, namespace. Sorry, I totally made that smaller. Okay. So there's our different systems that we want. I don't know about that apply. Well, I think it should be like this, right? Apply force physics component. I'm not sure about this yet. This might be right, but might not. What else was it? It was the force, which is a vec2. Oh yeah, that's right. I said it was a const ref. Okay, so we're not going to have a physics system anymore. So we're actually like completely scrapping this. I think so. Yeah, I think we'll just get rid of this entirely. So we do want to do, so actually, I think I'm going to put any like helper functions. I might move this, like maybe this will go elsewhere. But we'll put any of that stuff at the top. These like helper functions. So this is going to be, we're going to have 4 of these. something like this. So we're gonna have all these world manifolds. The world manifolds, I think I'll probably just leave mostly as is, yeah. Well, how do I specify for a world component whenever we're going to read or write it? I guess probably... I don't know what I want to do with that. Scheduler reads, scheduler writes, component bits. Because this is going to be, for world components, it's pretty different. Yeah, I'll need to think about that. So the world manifold, I'm actually just going to comment that out for now. I'm like 95% sure we will end up having this thing, but we don't need it until we actually have like a tile components or something. So it's going to be a while before we actually get to that point. Okay, so we said we're reading and writing with our transform and physics, so that's right. For our physics entity manifolds, we're going to be reading the transform and collision. And we need to write the world manifold. And so that's what I'm not sure about, is how do we handle that? I guess, can't we do something else? So I say it writes, can I do this? Can I say this is a collision, or sorry, a component ID? Component ID. Oh wait, no. This would be... How would that work? So I was thinking I could, because we have world component as something separate. So I could have like, is it a specialization in that case of the function? I could also just make a different function like write world. Maybe I could do that. Maybe I'll do that for now. Because I really don't know what I want that to do. What are you trying to achieve? Basically, I would like to be able to do something like this could work, right? Maybe I'll put rights at the top. Rights are more important. What was it? It's the, what was I calling that? The physics manifold, which is a world component ID. I guess I don't include world component here. So it doesn't, so this is a world component ID. So I want this to be different and call a different code than what these are. Oh, whoops. Oh yeah, duh. That's a component. Okay, yeah. I wasn't thinking that through all the way. That's not a type. This would be the component itself, right? But yeah, I still want that to be different. Right. So I want one to be a component type. I probably could do that. I think the easiest way to do this is to say writes world. That's kind of what I'm wanting it to do. And so that's a similar thing. But honestly, I don't know what we want that system to do. Yeah, we might not have it do anything right now. It might just be a no-op for the time being. It'd just be Rights World, and it just doesn't do anything. Yeah, like we could do this like whole thing. I don't know. I think I'm going to end up getting rid of that, or I need to really think that through. I don't think it makes sense to really spend time working on it. Which is making it so that you have to write before you read. But I don't know if that really makes sense with this system, or like, I'm not sure how that would make sense. With our manually scheduling things, like placing them in order, I think we're probably going to end up just keeping that, honestly. Like, the more I've been thinking about it. So we have the scheduler. It's responsible for running all of our game systems. And right now we add them in a very specific order, and they are ran in the order that they're added. I was thinking about making it so that with this read and writes world, we can, read and writes, we would know what's being read and what's being written to, like the components, and we could actually like be intelligent, have the scheduler be intelligent about when those components are running. Like we could say, hey, and maybe we will still kind of do that. Maybe we will, where we'll give it a specific order and we'll kind of move things around, but it will still be able to do things like, hey, if we're reading a component, then we will let other jobs or systems run that are reading the component as well. But if we're writing to a component, then we basically will lock that component, and no other systems will be able to run using that component, the component we're locking on, until that system has finished. So that's kind of what I want to do, I think, in the future. And so we'll end up using writes world, which just says like, hey, this component is being written to, no other systems should be able to run with this. So I think I want that. I was thinking about taking it a step further and making it so that it wouldn't run in the order that we specify. It would determine the order based off of everything and try to figure out like what's the best route. I think that's kind of complicated. That would be complicated to do, probably, like to get it working correctly. Because like even just taking our physics system, what we did here. So we're definitely writing before we're reading, but here we're writing our physics transform after we're reading it here. And so I feel like for the transform, we're going to be breaking that rule a lot. I don't know. It might be like, yeah, there might be some ways to go around that. Like maybe we can have a read before or whatever, which is like, hey, this thing is allowed to be read before we write to the, before we write to it. I don't know if that makes sense though, because like here our physics movement, we want this to run in a very specific order. So I don't know about that. Yes, I am using Visual Studio 19. But anyways, so yeah, maybe we'll just do this writes world. Right now it's no op. In the future we will make it so like it properly locks that component, so other threads or systems won't be able to run in parallel that want to write or read from it. So that's what the scheduling is for. I honestly don't know what we're going to be using initialize for in most of these cases. Initialize is like at the start. I think, yeah, most of the time we probably won't do anything with that. Like, I don't know what we would need to do at the like start. Yeah, I don't know, because they're stateless. It's like, what do we need initialize for if it's stateless? I don't know. Like, I guess it would be if we need to set up a component in a specific way, a world component where we're like, hey, we're going to do this thing. I don't know. I haven't come up with a good scenario for that yet. I don't know. For now, they are just empty. And I probably will just collapse them down for the time being, just so that way it's not taking up so much space, because I honestly don't know if we're going to do that stuff. What I might do is move it down to the bottom. I think I might do it like that. We'll do it like that. Kind of move that stuff around based off of how frequently it's used. Update's by far the most commonly used one. Like, schedule, initialize, and shutdown will always be just ran once. That's very specific times. Whereas update is ran pretty much every frame. I was just moving this. Okay. Oh, I also broke. Well, I'll fix it later. Okay, so we got that. I'm going to then move this up as well. I think I like that. Okay. Seems good. So physics movement. We can finally, I think, start writing code. We have all that boilerplate stuff down. Actually, wait. Let's go into our game. This is the core gameplay loop. We need to do our physics. So we're going to have not just physics, it's going to be called these other things, right? Physics movement, entity manifolds, and collision resolution. So we have movement is the first one. So we're just going to use this. The name is the namespace. So it'll be like that. And so we have three more. There's the entity manifold and collision resolution. It's kind of verbose, huh? It's quite verbose. Yeah. It's the one thing that sucks about this, I think. It's that. This namespace that's just stupid long. Oh, whoops. I changed that. That's right. This needs to be after schedule now. Yeah, I kind of don't like this. I'm not sure. Maybe we can come up with a better way to handle this. Okay, so we got that done. So now we can actually start writing our update code for physics movement. Apply gravity force. So what I might do, actually, you know what we could do with this physics world manifold right now is set up arbitrary area. Like we could make, maybe it's just the bottom of the world is, or the bottom of the screen, or something like that, is the world manifold. Yeah, maybe we can do that. So maybe we could use this. Yeah, let's do that. So we'll add this in as well. So for now, we'll do that. In the future, we'll actually set up tiles. So we'll use like a tile system, but so this is going to be the same as the other one, where we are reading transform components and collision components. Yeah, okay, I like that. Let's go over here. And we need to add in one more, which is world manifolds. Nice. Is there a way to move a line up? I don't know. Just declare that in here. I think I also complain about, yeah, I should complain about vec2. But we don't need to know about that stuff in here. Vec2 is probably a struct. "23 hours to pre-order valve index." What's that? Think you can do alt plus up arrow to move a line? Okay, let's try that. No, that jumps to functions or something. That is definitely interesting. What does that do exactly? Let's go to like world. Is that jumping from function to function? Yeah, it jumps from the functions. Actually, that's kind of cool. I didn't know about that. But that's jumping between functions. Valve VR. I've not heard about that. You want to link me? Okay, so we'll do that with the physics world manifold stuff. Go to main page of Steam. Oh, you're making me work. I just see Mortal Kombat 11. Yeah. What's this? This looks interesting. U-boat. Risk of Rain 2 is doing crazy good. Wow, Forager is doing really good too. Forager's actually... Oh, okay, never mind. Altered arrow moves lines for me. Valve index. Why is it? I think there we go. Let's get to English. CS. What was that? What language is that? CS. They're like Czech. Yeah, okay. That's what I was thinking. It was Czech. That was the only language, and it looked like a European language. So it's a new VR. I have to tell my brother about that. He was looking at VR stuff. How much is it? $1,000 for that. Oh, okay, and then you can do them separately. Alt plus arrow keys move. Yeah, it might be that I'm using Visual Assist and it's changing. That's cool. I haven't seen this game. It looks nice. This just came out. I like the colors. Anyways, give me 1 minute. I'll be right back. Just gotta take care of one thing really quick. Okay. So. Let's make this stuff happen, huh? Apply gravity force. Okay, so I don't know how to do that. Apply velocity to position. I wonder if we really should be doing it in this order. Apply gravity force. So what we want to do for now is say for auto, it's going to be entity, transform, and what's that on? Physics. World query. So we want to make a query with the transform component and our physics component. And so what we want to do is apply the velocity to our position. Probably first do gravity. I don't know exactly how we want to do gravity. Gravity. And then this is just going to be transform, bounds, x is the physics, velocity time, or velocity x, and then we need to do the same with the y. I really don't know if this is a good design or not. Have you guys ever seen something like this where you have the bounds, is the x and y, or like the transform position is tied to a rectangle? I wonder if it'd be better to do bounds. Yeah, it might be better to split those up. Where it's like position is x and y, and then size could be vec2. So instead of having a rectangle, it'd be two vectors, or vec2s. might want to do that. I might want to do that. Because we hardly ever want to change the size, right? Yeah, I don't know. That's where things get weird. It might be easiest to... Yeah, I don't know. I don't know if the best way to do that, like handling the origin. Like, let's say, so in Korea, this was a challenge I had where... Looks like I'm dropping some frames. Where, let's say that the we're rendering and we have the position where like the size of the frame is, yeah, I get the problem comes whenever we have the size of the frame be variable, and so we're changing the size of the entity, and that ends up manipulating its world space, or like you have to like reconcile like, wait, where is this entity's origin actually at whenever it changes the size of the frame? You know, it needs to like look like it's staying in the same place. And I had some challenges with that, and I ended up getting it to work by like, typically for like monsters and the player, it would be the bottom center was its like point of origin. But I feel like that's like a weird way to go about solving it. I don't know. But yeah, I might want to change this because size should typically not really change much. But anyway, so that's what I might change it. Kind of thinking I am. But this is what we'll want for the velocity. So that applies the velocity. That just moves the entity. We need to do gravity. And we also want to do gravity with one thing we need to keep in mind. It's going to be like gravity times the physics. What was it called again? Physics, gravity scale. So how do we want to apply gravity? Is that just like applying a force? Not quite though. No, it's not really. Because how does gravity work with the mass? I need to look up some actual physics. Gravity equation with mass. I forget the mass times acceleration of gravity. So it's just not the... Okay. Man, it's been so long, like... Dummies. I'm a dummy. It's so sad. It was 2 semesters, so 1 year of physics. I've forgotten it all, basically. Yeah, so it's mass times gravity. Right. Hey, look, that's a slug. And Earth's gravity is 9.8. Meters squared. Yeah, I don't know what we want to do with the gravity yet. Probably just make a const expression here. Whoops.
No, we want it to be a float. Hey, Damos G, what's up? Let me know if you have any questions. Happy to answer. Okay, so it would be the gravity. So let's see here. I think what we need to do. So this is the force. Net external force. This is really how we want to handle it. Is where we say physics dot velocity. It would be only on the y. Yay. Sneezing. And then this would be need to be multiplied by the mass. Right now, so this is the one place where we have the inverse mass. So that's actually like, seems like it's wrong. I wonder if you actually want to do this in game. I imagine you do for like box 2D. How do they apply gravity? Use world gravity. Float G. Gravity controller. Oh, they actually allow gravity to be, yeah, I guess that makes sense. Gravity can be in any direction. For our game, we can just, gravity goes down. We don't need to worry about gravity doing anything weird. World. Looking for gravity scale. Where is it actually applying the gravity? It sets the gravity here. I want to see where we say something like, gravity times this other thing. Here we go. That's what I was looking for. That exactly right there. So it is gravity scale times the gravity plus the inverse mass times the force. What's the force? Okay, so they are using the inverse mass here, but I don't know what the force is exactly. So that's the world, or the body. I remember seeing that. Apply force. So does this not have a velocity? Oh, it has a linear velocity. Wait. Okay, so the forces are tallied up. I see. Okay, that makes a little bit more sense. So apply force. Right. Okay, so maybe we want to do that too. Oh, that's kind of, I didn't even think about that. Yeah, I guess I'll have to mess with that. Yeah, I didn't think about that. We need to do some sleeping. We'll need to sleep our physics components. Right now they're always awake, but we'll need to be able to sleep them and also be able to wake them up. And maybe when we apply a force, we want to be able to wake them up like that. If so, this is kind of annoying. Because then we have to like check that flat or do something with that. And it's like, I don't know. Don't accumulate a force if the body is sleeping. So we kind of really just want to be applying a force to a center. We don't care about doing any torque. So this just applies the force. I see. Apply linear impulse. Okay, I see. So there's impulses. That's what I was thinking of as a force. And that's where we have the mass times the impulse. I see. Okay, that makes more sense. So we should, I guess, do that where we say there's apply force and then there's apply impulse. And so our impulse, that's where we need to be doing this. Apply impulse. Oh, this is impulse. There we go. And the force is actually just going to... So I guess I need to add that back in. I need to add in a force to do this properly. It doesn't do that. It just adds this force. So I need to go back to here. For some reason, I was thinking I didn't need this, but I guess I do. We have a force. Back to, which is the float. Yes. Right. Okay, that makes sense. And then if we go back to here, this is where we actually integrate velocities. I see. So yeah, that's where we take our force and we multiply it by the inverse mass. I see. Interesting. And then H. What's H? What is H again? I think I remember determining. Oh, that's the time step. That's right. We don't care about that. Okay. So this makes sense now. I think it does. So we'll say this, and then physics. That. Yeah. Physics times the force. Right now we're just doing the... Oh wait, but then how is... Yeah. I see. Yeah. Okay. I don't need parentheses around that. And then we need to figure out the y, x, which right now we're not going to do that. Right now, gravity is 0 on the x-axis, so we won't even do that. And this is x. So it adds our velocity at this point. Is that right? Yeah, okay, that seems right. And then we update our position. Linear dampening. I haven't heard about this dampening before. Physics. Okay. I see. Yeah, okay. So this is actually something I did for Korea. I just didn't really realize that's what I was doing. So in Korea, I have this thing called friction and then ground friction. It's because it's like, you know, let's say you throw a ball, if there's no like friction or dampening or whatever, that ball will just have the like velocity forever and it just never slows down. And so that could cause some problems, especially because of like some other systems I had set up. I don't know if we for sure need this dampening. Man, allergies are like making my eyes itch. Where's that at? Oh, it's over in the component. That's right. So I have this. I have 3 different frictions. Friction, ground friction, and surface friction. I don't even know what those all are for. We have friction, which is applied always. Oh, if you're on the ground, it applies the ground friction. I don't know what surface friction is for. Factor surface friction. I don't know exactly how that's used. But anyways, I did use this friction basically to be able to do that. Although I was kind of, I did it a bad way, I think, where it just applied it at a constant rate. So it's like, oh yeah, we have a friction of 0.2, and so it just decreases your velocity by 0.2 always. Isn't surface friction applied when objects rub against each other? Maybe that's it. I can look surface friction. Where are we using this at? So we apply the surface friction to the ground friction factor. So I guess we'd be looking for this factor. Factor surface friction. Doesn't look like we use it. In here, we expose it to... Man, my eye is bothering me. Expose it to Python. So maybe we use it in here. Nope, we don't use it. Wait, where's... Oh, we're not looking for py files. There we go. So we use it in one place. In dungeon modifiers. slippery ground. I see. I don't even know if we surface friction, but we don't store it. I don't see us storing it anywhere. Or like doing this git surface friction. I guess we do it right there for tiles. But how is it being used? I don't know if this is like actually being used or something. I don't know what's going on here. Factor, oh, here we go. Factor, I missed this one. So whenever you come in contact with the ground, I guess it will do something like that. I don't know. It was weird. But anyways, yeah, it might be the slipperiness of the ground. So we want to do something like this with the linear dampening, I think. After we calculate the velocity. Right, we can multiply it by this. So H, we don't need H, and so this would be physics, linear dampening. Alright, I'm just gonna call it dampening. I guess we need X and Y. This is where being able to multiply this stuff could be nice. Like how is this even working? Like that type V is a B2 vec. Hold up, I want to go look at this. Like it's, I guess, oh, okay, I see what's happening. Right. No, that makes sense. So like it's saying that, hey, we can add and divide this, the vector, and then finally we can multiply them. Yeah, that makes sense. Yeah. Yeah, that's nice that you can do all that. Yeah, it would be kind of nice because all these lines could be cut to like one, basically. What are you using that doesn't have those overloads? Yeah, I honestly should probably look at investing into a better vector class now that I'm messing with all this. I was just using the SDL rect, I think. I don't even know why I'm doing that. Yeah, you know, we probably should invest in that stuff. Maybe we'll do that like tomorrow or something. I'll try to like keep this focused on this now, but we probably should invest in a better vector class. I have something for Korea that it worked out pretty well. I could trim it down some, but it's mostly there that we could pull over. It works. Like vector classes are really simple. Yeah, it has a lot of overloads. I can, yeah. Yeah, we could definitely pull this over, I think. I don't know if it needs to be templated, honestly. I'm not sure if that's worth it. That's one thing I'm not sure about. Like, this vector class is good, but it has some complexity that I don't really need. Like, I can convert between these different types. So I can say, like, I don't know, it kind of was nice. I'm not sure if I like it. Or I could say, like, hey, this is a tile vector. And so, and tile vectors are integral, and they're 16 by 16 pixels. And so that way, if I say like, hey, I want tile 512, it knows, you know, tile 512, okay, sure. Well, where's that in, you know, pixel coordinates? Well, it's 5 times 16, 12 times 16. And so I can get, you know, I can convert a tile vector into a pixel vector or something like that. And it would automatically be able to do that conversion, kind of changing between those different spaces if I'm working with tiles or if I'm working with pixels. It's pretty nice. Yeah, it's pretty nice. I don't know if I for sure want that, but it was useful because it could get confusing sometimes whenever you're like, wait, am I working with pixels or tiles or what? But anyways, so well, we need to add in this dampening to the physics component. So yet again, another thing that we need to add, dampening. Okay, so I think that would be it for this. So we apply the gravity, and then we what if I should? Yeah, it applies gravity, dampening, and then updates your position. Pretty basic. So with just that, well, let's see here. So dampening should always be, it should default to like 0, 0. Force defaults to 0. The velocity should default to 0 as well. I guess I need to set up the mass, huh? Gravity scale. I guess we could just say that by default it has a inverse mass of 0, which means it's immovable. And then when we go create a world and we're setting this up, we can say, hey, the velocity is, maybe we could just say it's 0, 0 to start with. I do need to set up the mass to be, let's say, like 1 divided by 3.0. Does this work? Oh, whoops. My bad. Yeah, I do want to static cast that, I think. To a uint32, right? Or it's an int right now. I'll probably change that. Yeah, we'll do a vector class. We should. Oh, hit a breakpoint. I was trying to read after we write. Yeah. Scheduler writes. Yep. Yeah. I'm just going to say whatever. I think that just doesn't really make sense for us. I've said that a few times. I think it's okay. Wait. But I changed it. I guess I have to recompile that. Reads is -1. Wait. But I got rid of it. Shouldn't it be there? What the heck? Do I have to do like a clean build? Maybe I do. Yes. Oh, maybe it didn't stop. Oh, maybe that's what happened. I may have not actually completely stopped this program. Smelly Arc. How's the game? It's going good. It's going good. Just working on a physics system right now. There we go. Whoa, that gravity is strong. That gravity is very strong. Okay, so maybe that gravity is a little too strong. How are you doing? What was up with that? But hey, it's working, right? We have gravity working. I think it's because our gravity is always applying to our velocity, but our velocity is never... So our velocity is just continually increasing, right? I think that's our problem. Like, maybe we need some physics dampening to slow it down. Let's play with that. We'll just say the dampening is, wait, it was like 1 divided by... So if I say like 2, that means that it cuts it in half. Right? Or 1, okay, yeah, so 1 will actually cut it in half. So let's just do like 0.5. It was still increase over time though. Whoops. Yeah, I think we need a terminal velocity. I think that is needed. Oh, whoops, dampening dot. I guess I'll do it like this. Let's say 0.5. It's a little bit better. But... yeah, I think we do need some like terminal velocity. I didn't see that mentioned in here. We don't mention it. What's the terminal velocity for something? Whoops. Physics terminal velocity. At terminal velocity, air resistance equals in magnitude the weight of the falling object. So as it moves fast, right? Okay, that makes sense. Okay, that's more of what I was looking at. Density of the fluid. Yeah, I don't know if we really need to do like a terminal velocity calculation. Like this is definitely... maybe more than we need. Density of the fluid, that's like the air. Which is kind of cool, like... yeah, I mean... drag coefficient. Acceleration due to gravity. Mass of the falling object. I like how these different things come up. Yeah, we definitely don't need anything this complex. Like a 3D engine would use this, and I guess like a really complicated 2D engine might as well. Code all the physics, but with our very, very simplified physics system, we don't need anything nearly this complex. For Korea, what I actually did is added in a fall cap, is what I called it, which was the terminal velocity for the character or other objects. Just set the bottom of those 4 bullet points as constants. So what is this? This is the square root of 2 times the mass times the gravity divided by the density projected area of the object. Interesting. So that's just the area of the entity. The like bounds. This, yeah. C is the drag coefficient. Or CD. Okay. Yeah, so our yeah, I wonder if we really need this. I'm going to let's go back to here where we are solving. I wonder if they do it in here. Positional constraints. Which would basically be like, it would limit V. Yeah, I'm not sure what all we need for that. I'm just thinking about it. Wonder what games typically do for this. Physics, system. Yeah, that's basically what. F is a force. Force of the gravity plus the force of drag divided by the mass. Yeah. Okay, well, we might need to add that in. I mean, we're probably going to need to add something in here for that, but the basics of it is working. Like, need terminal velocity. I'm actually going to put it right here. Yeah, but we can do that later. We can move on to the next, the entity manifold stuff and start figuring that out. But before we do that, I'm going to take a 15-minute break, go eat some food, because I'm actually quite hungry already. It's only noon, but I'm hungry. I want to go eat. So I'm going to do that. I'll be back in about 15 minutes, and then we'll start working on the physics entity manifold. And so that's building the collision manifold so that way we know which entities are colliding, and later we will be able to resolve them inside of our collision resolution. I'll allow it. Oh, thank you. So I'll be back in 15 minutes, and we'll pick it up there. Okay, I am back. 15 minutes exactly. Nice. I'm getting pretty good at that. Kind of. Okay, so before I took my lunch break, we got it so that we have a very basic physics movement system working, which all it does is it reads through our transform, and our physics component, applies the force to our velocity based off of our mass, and then inverse mass. Yeah. Well, we're not actually applying any forces right now. And then we use gravity as well, times the gravity scale. So that's one thing we could do if we wanted to. Also, slow it down. We could say, hey, our physics data physics gravity scale is, let's say, 0.2 F. And so now gravity is only going to affect us, 20%. So it'll fall down a lot slower when we wee. But we don't actually have it hitting anything, so they just keep falling forever. Forever. So we need to now add in this concept of like collision. Did you chew? I did not. No, yeah, I eat really fast. But also, I left earlier, so I cooked a yam. So once the yam is cooked, I just after it sits for a little bit, the peeling it is like in 2 seconds. Just the skin comes off, and then I just unhinge my jaw and put the yam into it. I jammed the yam down my throat and make coffee at the same time. Yeah, I have dampening happening. I can remove that. And that should make it so it falls faster. Hey, Axelis. Welcome. Also, welcome, Ikarudo. Oh, there you can see there, it's going much faster. Yeah. I had dampening on the item. Yeah, so we need to add in some concept of some terminal velocity. Because it just keeps going. And we'll figure that out more. But yeah, for anyone joining, what we're kind of working on is we're getting our physics system set up, which actually is a series of systems within our game engine. So we have our physics movement, which we just did, which writes to our physics component and our transform component. And it's doing gravity. It's applying the force. Yeah, so it applies gravity force or whatever. Yeah, gravity force and other forces that have accumulated on that physics component. Yeah. And then our next system, which we'll work on, is our entity manifolds, where we're going to have a manifold which contains collision data. And it's going to write to our physics manifold world component. And read our transform and collision components. We also will want to do a physics world manifold. So there's entity manifolds and world manifolds. The world manifolds will be in the future like tile data, you know, like, oh, you have this, you know, these blocks of dirt that have collision data on them. So we'll do that. So we'll need to read some like world tile or a tile world component or something. I don't know exactly what we're going to call that or how it's going to look in the future. For now, whenever we do implement this, it will just be like some very basic thing. Maybe it'll be the bounds of the world. Like, hey, once you hit the bottom of the screen or something, or maybe a little bit below, above the bottom of the screen, it will be a physical, you know, collision. And we'll just have that be really basic. And then the last part will be the collision resolution, where we actually are checking to see, to make sure that the collision is resolved properly, and we apply the restitution and do positional correction and friction and all that fun stuff. So yeah, we're going to work on the entity manifolds first. So this is the first time we're going to be using a world component. So I think like the first thing we want to do is get our physics manifolds. Manifold physics, something like that, which is coming from world get world. Hold up, I don't remember. Did I add that in? Do we have a way to retrieve a world component right now? I think not. I don't think we do. Get. Oh, actually, no, I take that back. I think this is the get function without. That returns yes. Okay, that's it. We say world get physics manifold component, and it will give us that. Okay, our physics manifolds. Maybe I think I might do this for now and just put that as data. So then we have, I don't know. So then it would be data. Push back, or we're probably going to do in place back. But anyway, so this is the manifolds. This is what we're going to be writing to. What we want to do is iterate through all of our... Yeah, this is actually where... So this is probably like one of the biggest, the meat of our system. One thing we need to do is set up a spatial hash where... What we actually care about in this case is all of the collision information. So we want to initialize it with the world size. For now, so this is something I need to think about. Yeah, maybe I need to have that in somewhere like world.size or something along those lines. I don't know how I want to do that yet. That probably makes the most sense. And then the cell size. Yeah, this stuff is definitely going to be changing. Right now, what we can just do is say that this is a vec2 of, let's say, like 1024 by 1024. And the cell size is 64. We'll do that. This power of 2s is fine. It's good. It's good. So what that means is that we're initializing the spatial hash to be to have cells of 64 by 64. So whenever we're partitioning our entities, they will go into these cells. When I'm looking at this, I think you are a math god. Nah, I'm not. I was using other stuff. I do have a degree in mathematics, but I haven't done like much math for like over a decade. So I have a minor in mathematics. Will you use linear algebra like transform matrices? I don't know if for the physics, no. For rendering stuff, we probably will a little bit. Hey, Bill Eats Chicken. I'm making a 2D multiplayer automation survival sandbox game. You can think like Terraria meets Factorio type of thing. Side view perspective sandbox game, kind of like Terraria, kind of, very loosely, with more of like the automation side of things of like Factorio, where you have items moving around on conveyor belts. But I'm going to be using physics. We're actually working on physics right now, where you'll be like shooting items and having them bounce off walls and have like some type of like huge industrial sized fans blowing items around and stuff like that. That's the vision for the game. And yeah, you're welcome to ask more questions if you want to. But yeah, for anyone new or newish, I do stream development of this game every single day. This is projectDIG, and my name is Jason. And I have a schedule down below the stream channel. It's 8 a.m. Pacific time on the weekdays and 1 p.m. on the weekends. And I'm also putting all the VODs up on YouTube. So you're welcome to check that out as well. And I actually did a recap earlier today, and I'm going to be posting that on YouTube as well. And we'll do like bi-weekly recaps. So if you can only, keep up every once in a while, there'll still be a way for you to like quickly kind of catch up. I'm using SFML. Is it a good start for 2D games? Yes, actually, the game that I worked on for like the last 7 years, Korea, uses SFML. There's a link to Korea. You can see it. So yeah, it's a great. I think SFML is great. It has some problems with commercial games, but you can definitely do commercial games, and it's good. It's good. I think it's good. I think that the developers have done a good job. I decided to go a different route for this game. I'm using SDL and everything. We're doing our own game engine here. But yeah, I think that SFML is good. Hey, welcome back to Chemist. It's going. We have some basic like gravity applying to our physics. We're starting to add in our physics entity manifolds. But yeah, you guys are always welcome to ask questions. Happy to answer. So, we're initializing our spatial hash here, and then what we want to do is populate it with the world. We actually only care about, so this is a pretty cool little system I have here where you can say, hey, I want this hash map to be populated with all of the entities that have a collision component. So that's pretty cool. So I just realized there's a small little issue with this. It's probably okay, but it's something to think about, which is that if I'm using the collision component, or if I'm like requiring it to have the collision component, which has a bounds as well, then I'm using the transform bounds to partition the entities into these different spatial or into the spatial hash. And the collision has its own bounds as well, which means, but we'll be performing or creating the manifolds with the collision bounds. So potentially we could have like some issues where something collides whenever it or something is not colliding whenever it should. I think that would be the case. So I might need to do something with that. It's only a problem if our collision is larger or if it goes outside of the bounds of our transform. If the collision bounds are always contained within the transform, then we're fine. But yeah, it's just something I need to keep in mind. Okay, so we have our hash map populated. That's good. So now we can do a for auto, and we're going to iterate over all the transforms, right? In collisions, yes. Entity, please don't do that. Transform and collision. Man, I love the syntax. It's so sexy. It really is. World query on our transform component and our physics component. And what we want to do is just like, so we're iterating through every single one. And we need to create these transforms. One thing that is kind of a problem that we're going to have here, and I think this guy actually mentions it. Where is that at? In here? Maybe it's up over here actually. Objects collided. Okay, maybe he doesn't actually talk about it. Thought he maybe did, but I guess not. Well, anyways, is that it does look nice. Hey, Bill eats chicken. Bill eats chicken. I'm just gonna call you Bill. You're welcome to ask any questions about what I'm doing. But yeah. You're welcome. Anyways, so the problem here is that, let's say we have, we'll just use his diagrams over here. You know, let's say looking at these two, they have collision, or whatever. I mean, whatever. One of these. Let's say these two circles. We're not doing circles, but whatever. They collide. If we're creating manifolds for all of the entities, what we're doing is we're iterating through all of them. So let's call the big one A and the small one B. And so we're iterating through, you know, A, B, C, D, whatever. We hit A, we're like, oh, there's a collision here with B. So let's make a manifold. And then we'll get to B and we're like, hey, there's a collision here with A. Let's make a manifold. And then you're like, wait, we already have this manifold. This is like the exact same thing. We need some way to like see that these are the same and not try to resolve that, or like I mean, not resolve it, just see that it's a duplicate and not add it to the list. Like as soon as we're like, oh hey, there's this collision with this other entity, oh, we already got that collision, never mind. So we can think about how we could do that. I have one possible idea on that. Yeah, you're welcome to watch the VODs. I've done all of the development on stream, like all of it. It is a lot of content. It would, you know, I'm streaming somewhere between 4 to 7 hours every day, or 4 to 8 hours every day for the last 2 weeks. So it would take a while to catch up. But there's a lot of content there, so you're welcome to like skip through it and everything. It's definitely not that dense. I mean, it's a lot. Some of it's more complex stuff, but like, you know, I waste a lot of time talking like I am right now. So here goes skip 1 minute, skip 1 minute, skip 5 minutes. Here Jason goes again, another tangent, skip for a few minutes. So we need to ignore duplicate manifolds. So what I was thinking we could do to get a unique, like to hash these, maybe, like we could create a hash of it, of the manifold. Basically the hash of a manifold would be this is what I'm thinking. Entity 1. I don't think I'm going to do this, but I'm just writing it down. So that could be the hash of it, because it's just the two indices. And that's always guaranteed to be unique out of the two entities. I take that back. What happens if entity 1 and entity 2 are flipped around? That's right. I would have to, in order for this to work out, I have to make sure that I had some strict ordering where it's like entity 1 is always less than entity 2 or something like that, or it is always greater than. That's what I would have to do for that if I wanted to do hashing like this. I guess actually I take that back. What I could do is this. I mean, it might make sense to, yeah, it would make sense to do it here rather than, like, we'd want to keep this as simple as possible. And honestly, it would probably be better to store it as an ID or something. Well, that's what I was thinking. So anyways, I was thinking what we could do is generate that ourselves. So we could have for now, we could just have an unordered set. We would probably want to replace this with something else. And it could be a uint32 set. And these are just like the manifold IDs or something like that. And so anytime that we're going to create a new manifold, you know, we detect some collision, we can just I think it's insert, right? Yeah, insert this new manifold ID, and then manifold ID is going to be pretty much exactly this, but we could do it like this, where we say entity 1 dot index is greater than entity 2 dot index. Then do this, otherwise flip them, so that way they are always the it's consistent that the larger one is in the front. How do you know what that math symbol means? Send a book where it explains what that symbol is. I don't understand that symbol. Sorry, what symbol? This ... one, or what? I don't know what symbol you're talking about. Yeah, he says right there, it means therefore. It's used to, like, whenever you're writing some, what is it called again? Like, this huge, you know, like, yeah, whenever you get into more complex math, they do that. where you're trying to solve this equation, and you're like, hey, I have this thing, which goes to this thing, which goes to this thing, which goes to that thing. Therefore, this is true. He uses it kind of weird here. That's typically not how it is. I mean, like, you can do it like that, I guess. But typically, I think it's how I described it, where it's kind of like, therefore, this thing is true that I'm proving. That's what I remember, at least. Maybe I'm wrong. So yeah, our manifold ID is a UN32, which will just be what I wrote down here. It'll be like that. We don't have an entity 1, 2. We have entity, and then I don't know what the other one's going to be. So we actually wrote something kind of like this earlier. I have a master in physics, and I never saw these 3 dots. Really? I imagine that with physics you had to do a lot of math. I vaguely remember using it in like 1 or 2 places, but I think it's mostly for like kind of really complicated math. Like, well, I imagine you had to take like calculus 3 and stuff like that. Like I took calculus 2 and 3 in college. I think I used it in like 2 or maybe 3. I don't remember. It was like 14 years ago now. At least a decade. Another lifetime. So, yeah, it was in our physics here. This is where I removed it. Out of bounds. Yeah, delta. Do I need the delta? What was that? Delta x. Oh, that was for figuring out the collision. Yeah, so we don't really want to do that. But this. Query cold. Yeah. I guess what I'll just do is discard that line. We'll do that. Yes to all. Oh, this is going to end up going into here, and so this could be entity 2. Maybe we will call that entity 1 and entity 2. So this is our entity 1 and entity 2. Fortunately, we don't have any. Yeah, so this is the query cold. So we get our transform bounds. So actually, we don't quite want that. What we're going to want is, that's right. I didn't think about that fully. No, did I? World component. Okay, I do have bounds 1 and bounds 2. So we can calculate bounds 1 here. Which is the transform. I guess we could do it. Transform. Right now it's bounds x plus, it's actually going to be collision bounds x So I'm not sure if I'm going to keep it like this. I might change it. So this is width and height. Collision should... Oh, whoops. Aha. That was wrong. That's a collision component. There we go. Is it better to program C++ in Windows than Ubuntu? It doesn't matter. I think maybe Windows might be easier because there might be more examples online because more people use it, but I think that you still have to learn either one. So do what you're comfortable with. If you want to use Ubuntu or something, or Linux, whatever, then you can do that. PHP devs are real devs too. I disagree with that. No, just kidding. Okay, so this is our bounds. So this is our collision and transform bounds. So then what I want to do is say, okay, we're going to query on that. And so that's why I was saying it could be broken. Because and this is probably, I don't know if this is actually going to be a problem, but really like our physics component, yeah, I don't think this is really going to be a problem because I think almost always our rendering bounds is going to be larger than our physical bounds. Like, yeah, I think that always makes sense. Okay, so that's our manifold ID at that point. So this is actually things that are touching, so they're overlapping because this is calling the entities at that point. So this is cool. So these are actual like collisions. So first what we want to do is calculate the manifold ID. And then we want to say if the manifold IDs, it has a contains, that's new. If it doesn't contain this manifold ID, then we can insert it. Yeah. So what we'll do is we'll say manifold ID, IDs, insert this ID, manifold ID, and then, so we're gonna get rid of that. And at that point, this is when we want to do our in place. We'll probably do it right here. So we need to create a new manifold for it. So we'll just say entity 1, entity 2, our bounds 1. We can do our bounds 2, which will be really simple. Right. We have our entity. I guess it's not quite as simple. We have to, at that point, ask for the collision 2. Oh, we have to ask for both. That's kind of annoying. Oh well. Yeah. So we have to do a world get transform component for entity 2. And we need the bounds for that. It might be easier to just do this. Then we have to do the same for the collision component. There's something on my key. Okay, so that then will give us this. We just have to add in 2 so we can get our bounds too. And what's the last thing? Oh, this doesn't work. That's right, because our struct doesn't have a constructor. Or restitution. Oh yeah, we have to figure out the restitution between these two anyways. Right. Which is float restitution is the min between the collision restitution and collision to restitution. I don't think this will work. We'll see if it compiles. Yeah, I don't think it will. I think I need to... How do I need to do this? Whoops. Check. Oh, right. Yeah, that's right. The shifting is like super low priority. That's right. Thank you for reminding me. It was going to do the entity index plus 14 and then shift the index over by that amount. That would be bad. Yeah, we don't have a manifold. We can't construct it like that. Is that worth doing? You can insert without checking. Yeah, that would be nice. I was actually thinking about that. Does insert return? I really need to switch over to different solution. Okay, so the second value returns a bool, or it includes a bool. If I insert the value type, yeah. I see. Thanks. Restitution. I swear I know how to spell it right. Was this a typo? Yeah, so how would I check that in here nicely? I guess it's a second, right? Yeah, insert second. Sure. That's cool. Whether it took. So it took. Yep, okay, that works. So it says that we successfully inserted it. So our current problem is with this manifold. We don't have a constructor for it. I remember us talking about this before. I don't really know, like, I guess I don't fully understand this. The in-place back. Versus Yeah. What did I do before? I think I just do pushback. If I recall correctly, people were just saying it doesn't make a difference if I do it one way or the other. Basically does new mem_t forward arguments. It just calls the constructor. Right. So it calls the constructor so that way it doesn't. Whenever you're constructing it, you won't have to be like creating it multiple times, right? So it doesn't. So like and I think move semantics kind of make it so in place isn't as necessary, right? Because like the whole idea behind in place is to avoid that extra, like you allocate, you create the object on the stack and then, oh, now you create this new object over here, or you're having to like copy it or whatever. But with if you're doing it like in place back, we'll construct it in place, right? So like here, I was thinking we could use in place back because I want to construct it in place. We have all the args. I just want to have it constructed in place. But the problem is that it's a struct, and I don't have a constructor for it. And I was just trying to keep it plain old data, but maybe I do need to actually add in a constructor here so that way I can use in place back. Would that be like the correct solution here? Or is it not really going to matter because it's just going to do like a move with this place or pushback, and so this moves this into it. So it's more or less the same. Like we're not wasting the extra effort. Like it's not allocating this object on the stack and then pushing it into this manifold as well. Something I'm still learning, trying to understand like what's needed and when, or like just the whole like move semantics. Like a lot of that stuff happens behind the scenes, and so it's like it's kind of hard to know what it's actually doing. Yeah, I don't know. Anyways. We can worry about it more later. It's something I need to like just do some reading on, I think. So this will create our manifold for this entity, or those two entities that are colliding, and push it. Push it onto this physics manifold thing, and we make sure it's unique with the manifold IDs. And so this, I like doing this because it just keeps that in here. So we don't have to worry about like the uniqueness outside of it. This is like, yeah, this is unique. This is fine. And it will make iterating over the manifolds nice and simple as well. So we're kind of like keeping this added complexity of the manifolds being unique within this little function. It's not very transparent, and moving doesn't even save you anything when you just have value types and no pointer references types anywhere. I see. Yeah, I think I just need to do more reading on it. I've read a little bit, but not nearly enough, and it's something that I don't have much experience with. But anyways, this seems good. Nice and simple little function that creates our manifolds. So that's cool. Let's then, oh, so actually, yeah, that's fine. That's fine. So now we'll get to our physics world manifold. So we need to also populate this. I think in this case we'll just have entity 1. And so that's where we want our entities to be able to collide with the world. And so we also want to push our physics manifolds into here. So we should actually first get that. I think I'll do that. Manifolds, create our hash. Yeah, I think that's okay. Transform, collision, yeah, this is fine. What we just want to do is have it so that it collides with the, right now we'll just say the bounds of the screen, or maybe a little less than that. In the future it would be the tile component. And so we actually did the bounds already of the screen, which is just that, this right here. Kinda. I mean, I probably don't even need to do that. So it would be if the entity, no, transform, or I guess it's collision. Right now we're going to say that the collision is the size of the, oh, that's right. We have our bounds here. We're having to calculate this twice. That's kind of annoying. That kind of sucks that we have to do this twice. This is our bounds. Yeah, that's a little too bad. Yeah, that kind of sucks. We might need to come up with a better way to do that. Because we're actually going to be calculating it a bunch. Like, I mean, it's not that expensive, but we have to calculate it, or yeah, we have to calculate it here as well whenever it has a collision, and here. So we're doing them at least once, twice, maybe like 3 or 4 times. For every single collision, we do it an additional time. Yeah, I don't know. Would it be worth doing another iteration over just our collision component? No, it'd have to be transform and collision. I don't know if it'd be worth it though. Anyways. So we just want to say is if our bounds is less than 0, or if our bounds.x is greater than or equal to this size of the screen. Right now it's 800. Or if the bounds is maybe I'll just do this screen world bounds. I might actually do like 50, 750, oh whoops, 50, 50, 750, and then the height is 600 to 550. So then we could just say here world bounds x is greater than or equal to do I want to say less than or equal to here? I think so. That means that there is a collision. Yeah. It's greater than or equal to world bounds dot. That's right. I need to do the left size. Bounds plus bounds dot This is one thing I really like about my rectangle class, which I'll probably be going through here and changing, is that I just have like a right side or something like that, so I can say right instead of like x plus the width. This little helper function that makes it much more concise. Whoops. I'm just going to do the y-axis down here. Okay, cool. So this is just checking to see if they collide. Right now, we just have it be the world bounds. So if there is a collision here, we just need to push this. We can do the restitution check as well, and maybe we could just we can have that be defined float world restitution. Whoops. Is like 0.5 f, so it's like it's in the middle. So there's some bounciness to it. World restitution. Entity 1. So this is the awkward part here because I don't have. I might need to set that up. So that way I can say like, oh yeah, this is a null entity. Yeah, I think I need to do that. I don't know. I might do something like this, or I don't know. How should I do that? What would make the most sense? Would it be like this maybe? Null? I don't know about that. I don't know. I'm not sure what I like about that. So bounds. Should I really have it be like this? So the weird thing about this bounds is that it is containing the thing. Maybe what I should do is have it be a list of rectangles. Kind of thinking that might be better. Something like world bounds. I can do that, right? I think so. It'd be like 0, 0, 50, 50. So that's one rectangle. So world bounds, this would need to be a vector. Or an array, whatever. We could have another one on the other side, which would be 550, 0. I guess we want to start it at 50 down, right? Wait, 0, 0, 50, 50. No, that's not right. We want it to be along the side. Starting at 50. So it should be 50, 50, or I guess it could start at 0. and it's 50 wide, that's right. But then it needs to be the entire height of yeah, I think it needs to be more like that. And then it'd be 550, 0, 50, 600. Which just says it's on the other side, or not 550, it'd be 750. So what we're doing is basically like, if this is our world, or our screen right now, then we are drawing a little square like right here. And then another one over here, or something like this. Does it need, it'll be something along these lines. They're going to probably overlap some, but yeah, it's something like this. Maybe another one up here. We probably don't need the top one really, but yeah, something like that. And so they'll, you know, be able to bounce around in here. Yeah, I probably won't do the top. The last one, if we don't do the top, the last one would be on the bottom, so we need to go down. 550 would be the start of the Y, and it lasts for 750 going across. Or no, sorry, it would be 800. And it's 50 tall. Yeah, that should be sufficient. So by doing that, then we can just say if, or sorry, for rect world bound. Maybe I'll have to say bounds too. In world bounds. And then this is checking if there's a collision. If has intersection, whoops, between bounds and bounds 2, then that means that we should add that in. Yeah, and so now I just have to world bounds. Oh, whoops. Get rid of that. I just have to figure out this entity null thing for this. What do we want to do? I kind of like null entity. Maybe I can just do 0. That doesn't quite work because it needs to be an entity ID. Can I do something like this using entity? No, wait. What would it be? Yeah, I think we could just do like a const expression static entity ID or entity whatever is 0. Can we not do this? Oh yeah, we can't do a const expression on that. Duh. Yeah, I also need to say like entity null. I'm pretty sure that doesn't work because it const expression. I don't think. Does that work? Oh wow, that does work. I don't know if I like that though. I feel like there would be a better way to go about doing this. But yeah, this would be the case because that means that generation, index, and type are all 0. And so what we can do is go to our prefabs. And when we set up our prefabs size, so we reserve it. So what we'll do is we are going to push back a new prefab that is not used ever. So this is an invalid prefab. We don't set it up. I guess I should do that. Maybe that'd be the best way to do that, is to just say whenever we're initializing it, call create, right? And that sets up a prefab that's empty, that doesn't use anything. We technically don't need to reserve any components for it, so I guess that's true. We kind of don't really want to do that. Is this an empty prefab? We do need to set the ID. Right, I guess we could do it the other way. We could do it like this. Since we don't really need it, we could say prefabs. When prefab 0, the ID is 0. And so that reserves our prefab index 0. It's invalid. You could do a static member function to create the null type. That seems to be the way math libraries like to do it. A static member function to create the null type. Really? Inside of the entity ID union? Can you do that in the union? I don't really know how unions, like, you can't have functions or anything inside of a union, right? Can you? Maybe you can. I don't really know how that works. Oh, it can, but not virtual functions. Okay, sure. Just unusual, right? Yeah, I was thinking it could be nice to be able... I don't know about the whole null thing. But... yeah, I don't like how that looks. I'd rather be able to do something like entity null or entity null or something along those lines almost. Like, could I do a, and I don't know how it works with the union, but like a static entity null is equal to 0. Oh, that needs to be a const expression, right? I guess I could do it like that. Is that weird? Why have a fixed null? Because 0 is null. Well, the thing is that whenever I want to compare or like pass it around, not to create a type of that. Well, seems like a sane decision to me. Yeah, I don't know. I kind of like it because what happens if I decide that null, this doesn't work out and I want to change it in the future where like maybe the null type is actually going to be uint32 or what is it, max uint32? Is that, or uint32 max? Yeah, or something along those lines. And suddenly it's different. And so this would make it so, especially if I add in, oh, I do have an operator for this, right? What does that do, actually? Yeah, it compares to UID. Yeah. So that would mean that I could compare them and just say, hey, is this null? In your code base, by convention, treat any zero value assigned to pointers or ID as null. Interestingly, you can't do that. So then if I didn't do this, I guess what I would have to do, wait, where am I? Physics. If I don't do that, I would have to say just like entity, right? And no, that doesn't work. I think I need to do it like this, right? I mean, like, how would I need, whenever I'm creating this manifold, it's expecting an entity, which is, it's technically a union with this UN32. So I can't, and maybe I need to add in, I don't even know if I want to do this, some implicit conversion of an int to a I don't know. I kind of like this, honestly. Well, I don't know. Do I entity null? Do I have a convention for a null entity? That's what we're trying to come up with. Entity null is fine. Yeah, so I'm just trying to think of like, assign it to 0. I am. Right here. So that way I can nicely be able to say, like, you know, later on I could say if entity is, alright, I'll just do it right here. I could do, you know, stuff like, if entity is equal to, why do you always do that? Entity null, then do this thing. Yeah. It's also possible to do it, I don't know, I kind of like this. It's very explicit, whereas like, yeah, technically entity UID is, you could do it like this. But I think I like this. It just means that, yeah, I have to make sure that I reserve at least one of the 3 components that make up the entity ID. So the 0 is reserved. So either the generation index or the type. And I think it just makes the most sense to have type be reserved. So 0 type is invalid. Is null. Yeah. I could do operator overloading. Yeah, with the bool. Sure. And maybe I will. I don't know. I don't know how much I want to do of that. And maybe we will. I mean, we could do like a bool operator. I think it's something like that, right? with the entity. And it's something like that. I forget what it is. Yeah, I forget. It's something like that for the bool operator, so we could, you know, just say, hey, is it equal to null if we wanted to. Maybe we will. What I do is create a dummy entity which gets the first ID 0, and that entity is not used again. Yeah. Sure. Yeah, I mean, no entity is ever going to be possibly assigned to UID 0 either. Because we're reserving the type 0. So, like, the lowest entity UID we can have is 001. Which I think is fine. As long as we have a unique entity. So we're just saying, hey, there's no archetype with index 0, except for our entity ID is 0, and so that technically has that reserved one. Yeah, I think it's okay. Hey, Miggity. Welcome. I'm working on a 2D multiplayer automation survival sandbox game. I'll do a little dig. You're welcome to ask any questions if you have any. Okay, so this will do entity null. We got that. So I think we have all of our bounds being set up. Now we just have to actually do the collision resolution here. So that's writing to our physics and transform. So we have that. And reads are manifolds. So we need to say reads world physics manifold component. Stephen Wolfram. Didn't think that would work. Yeah. Please call me Mig. Yeah, can do, Mig. Wolfram, that's like the mathematician, right? Like the Wolfram. Yeah. That's funny. Okay, so this last physics system, the physics collision resolution, is writing to our physics and transform components and reading our physics manifold world component. And what we want to do in here is resolve the collisions, apply the restitution, do positional correction, and then apply friction. So it's quite a bit of stuff. It's kind of like the heavy, you know, this is where a lot of the logic is going for the physics system. So resolving the collision. This stuff is like definitely the most complex part of it all. So we're looking at, was it this stuff? Yeah, but I feel like a number of this stuff is wrong. I don't know. I don't know about this. Let's see here. So we have our manifold. So we know what the overlap is, right? Or where the well, we haven't actually calculated where the overlap is or how much there's an overlap. We just know there is an overlap with the manifolds. So like probably the biggest thing we want to do for the system, at least to start with, is say for Or first we have to get the physics manifold. This is where we are reading it. So we'd say for auto, or I don't mind doing, what is this, manifold, manifold in our physics manifold. So we're iterating through all the, oh, this needs to be data. So we're going to be iterating through all of our physics manifold data, and we don't need to be able to read it, so we'll say it's a write it, so it's a const. Our manifold information, here it is, entity 1, entity 2, balance 1, 2, restitution. So that's what we're storing in there. The restitution is how bouncy it is. I don't know if we really need to do this because we're always constructing it. Maybe I'll just like, I don't know, it doesn't really hurt. I guess it doesn't hurt anything. I don't think so. So we're iterating over the manifolds, and we have to like resolve it. I'm not really sure what I want to do with that yet. Or like how to do it. This is what I did for Korea. We're looking at this other guy's solution. So he actually does more stuff with his manifolds. I don't know if it really matters. When we do that. Penetration depth. So we should probably do this within this loop with the manifold. So I'm thinking we can calculate excuse me. We can calculate the normal and the penetration inside of here, like, yeah, inside of this loop, and then use it for that manifold. Like, we don't have to store it in there. I don't think so. Did you get manifolds from this guy, or is that generally a part of an ECS? Manifolds is generally part of physics systems. So like box 2D has manifolds. Not in there. I don't know where they are creating it. I guess it would be in the solver. It wouldn't be in that one. Yeah. Collision. B2 manifold. Let me see. Oops, wrong thing. Probably in here. No. Where are the manifolds at? Must be in one of these. Seems like manifolds are not really exposed. Some struct. I don't see where it's actually defined. Maybe I need to search. It says it's a struct, so I saw a forward declaration for it. There we go. It's in B2 collision. Got it. Yeah, I should do some reading as well. A manifold for two-touching convex shapes. Box2D supports multiple types of contact. Clip points versus plane with radius. I don't know. Manifold points. The points of contact. So this is probably more complicated. Yeah, there's local normal, local point, type, point count. Yeah, maybe in the future we would have more complex manifolds or something like that. Right now it's like really basic. All it really is information on that there is a collision happening between these two objects. Sounds like typically the manifolds contains more information on the contact itself. But what I'm really just doing is saying, oh yeah, these two objects are touching, and we're going to need to resolve that later. Yeah. But this guy does not that great of a job in this. Like, whenever I first looked at this, it looked really good. But to be honest, the more I've looked at this, the more I see all these issues with it, and how it's like, it doesn't actually tell you how to, like, there's a lot of holes missing. For one, there's no like overarch or like example of like, oh yeah, the code needs to flow in this way. Like, he talks about this penetration stuff over here, but you don't calculate the penetration until you are down here. And so it's like not even in the order that you're... Yeah, so it's like out of order, and he never actually gives you an overview of how it's supposed to work. Yeah, I don't know. Anyways, I'm trying to figure out how to properly handle this not the circle, this right here, kind of. So like, I guess we need to calculate the penetration. And with that, what was the other thing called? The impulse, right? Whenever they hit each other, there's like some resolved collision, this right here, right? So we calculate the normal. Whoops. I think the normal is the normal of the velocity along normal. I don't know what this is. I think this is the normal. Calculate, yeah. I think this is the normal from the manifold that you're supposed to be using. So we calculate the manifold, the normal here for the manifold, and the penetration for the manifold, and then the penetration is used with the positional correction. And the normal is used up here to resolve the collision. I think that's how it's doing it. So what we probably need to do, I don't know if this is completely right, this code here. The dot product. Minimum. We have the restitution already figured out. Calculate impulse scalar. 1 minus e plus e. What is e? E is the restitution times the velocity along the normal, which is the dot product of RV and normal. RV is b dot velocity minus a velocity. Okay. And then we can, I see, the impulse. Gotcha. That's the inverse mass. Okay. So that makes sense. Hopefully it's right. So the first thing, one of the things we need to do is we need to calculate the normal, right? Well, the normal is actually going to be a vect. We could do an int vec2 right now, or maybe we'll do a vec2. Let's just do a vec2 normal. Right now we're going to say it defaults like 0, 0. But we'll actually need to set it, and we'll be calculating it later. And then we also need the penetration, which is going to be, I'm guessing it's the penetration on each axis, right? X overlap. Oh no, I guess it's a float. It's whatever one is greater, right? Or something. If X overlap is greater than the Y overlap, then it uses the X overlap. Yeah, it goes for the one that's larger. So I guess it'd be like float. Yeah, penetration 0. And then, so we have to like populate that with correct stuff. That's going to be here or something kind of like this. There's at least like 2 or 3 issues with that code though, that I've seen. So once we have the normal, I think that's the biggest thing, is that once we have the normal, we need to do this. I don't actually have anything for the dot product in here, so I'll have to, well, I have the dot product over here. I guess I can just steal that. It's really simple to get the dot product. It's just x times x plus y times y. And so, yeah, we can just do that. I'm probably going to change this stuff. Right now, I'll put it in a math file, but I think I might, I don't know. I'm torn between doing stuff kind of a little bit more C or doing stuff with like object oriented. I don't know. So we want the dot product. That should be a float. Get or a dot product of const vect2 position 1 const vect2 position 2 dot product. This is just position 1 dot that, position 2 dot position 1, position 2, whoops, turn that. Okay, so that's our dot product. So we want to do something like this. So that's our relative velocity. So we'll say float relative. Wait, is that really float? No, sorry, it's a vector 2. Relative is the Oh, yeah. So we're going to need to get our physics at this point. Right? Yes. So that actually ends up kind of working out. I didn't realize that. But that's kind of nice that we don't need our physics component here. But we need it whenever we are going over our manifolds. So we have a manifold. So we're going to say like physics component. Probably just do physics 1 is world get physics component for manifold entity 1. And so here we need to actually check if our, like, what happens if physics 1, what do I want to do for that? Because our physics 2 might just be nothing. In which case, we don't really want to do a lot of this stuff, right? Maybe I can simply, yeah, I might be able to do it like this and just say if physics, oh wait, sorry, manifold entity 2 is entity null. So if that's a null entity, maybe because it's like we don't need to do b dot velocity plus, you know, the b mass, like this is 0. So it's going to, whatever the impulse is, like this is just wasted time at that point. And like we know this is going to be 0, so we don't have to do that. So there's a number of things here, like b dot velocity is going to be 0. So like our relative velocity is always, you know, the physics 1 velocity whenever we don't have anything. So it's like we can simplify a lot of this stuff, basically. Oh yeah, I have it equal to, but I don't have it not equal to. That's right. I probably should do that, huh? That's really simple. It's just that works. You can also say like, yeah, I think that's the easiest. The reason I want to do not equal is because I think that's kind of like maybe the more common case, or to like the more complicated case, so I prefer to do it first. So this is the relative, which is going to be, oh yeah, and so in this case we need to get physics 2. The other one, there's no physics 2. Okay, so this is going to be physics 1 velocity, or whatever, physics 2, it doesn't really matter. X whoops. This is where having some better classes would help. So that's our relative velocity. And then what we need to do is calculate the dot product velocity along the normal. Normal velocity, I don't know. This is going to be the dot product of the relative velocity, and the normal. Oh, did it? Oh, whoops. Whoops. Wait. Oh, sorry. Yeah, that's just a float. I guess it does make sense to normal velocity. It's not really that. Maybe it is long normal. That's such a long name. Whatever. It's very clear, at least. Do not resolve if velocities are separating. I see. That's if it's less than velocity along normal. If it's less, it's if it's greater than. Velocity along the normal is greater than 0. Is that right? If it's separating. I see. Okay. And then we need to calculate the restitution, which we already have. That's in our manifold dot restitution. And then do the impulse scalar thing. Let's see. So that's this right here. One minus, yeah, okay. So J, can we have a better variable name than that? This is along the, this is the, right, that makes sense. I don't really know what J is exactly. It's just in this equation. J. Manifold restitution. And then it was times the velocity, right? Yeah. The velocity along the normal. And then it does J divided by the inverse mass of each one, which is physics 1 inverse mass plus the physics 2 inverse mass, which we already have pre-calculated, yeah. which we could technically put into a single line. And then lastly, we need to do the impulse. Vec2 impulse, which, oh yeah, that's right. Okay, sure. I wonder if it matters which one is B and which one is A here. Like, if it doesn't. Because we say like A dot velocity is minus this. Maybe it doesn't matter because it just is flipping them. Maybe. I'm not sure about that. It's the normal. Well, we can't actually do it like that. We need to right now say it's like J times the normal dot X and J times the normal dot Y. And then we can finally do, we apply it directly. Like, so we have our impulses up here, but we want to do it kind of a special way. Physics 1, physics 1. So we're doing minus on physics 1. And plus on physics 2. Okay, so we still have to set up the normal, but that's what it's looking like there. For if we have a null entity, we need to do most of this, but it's going to be simpler because I guess this would just be relative as negative. Is that right? I feel like this might be a little weird. Say it's negative, the dot product, or like, is it possible that this could ever be? I don't think that it's possible that this could ever happen. Like, that means that they're like separating, they're moving away from each other, but one thing isn't moving, so that's not possible. I don't think we could ever run into that scenario, so that check is not necessary. This is always 0, so we can just do it like that. Impulse, that's fine. This doesn't exist, so we don't have to do that. So yeah, it gets simplified quite a bit. Whenever we have, so yeah, that's when the entity 2 is null because it's the world, which doesn't move. Okay, so we need to calculate the normal and then the penetration, and we'll be doing the penetration here as well. We might actually do A dot position. Oh, this wants to write. Oh yeah, that's right. We do want to do that eventually. Yeah, so I'm thinking we might do that right there. So we have like the percentage and the S lop, the slop. What is this? Oh, that's the jittering. Yeah. Yeah. what we'll probably do is do a constant expression here. So this is the correction percentage. I don't know what the SLOP is. The K slop. Look how bad. He says it's K slop here and then it's slop here. I think he kind of forgot to try to compile this code or something. Yeah. I don't know what that is exactly, but we'll move it so it's like up here. Yeah. Oops. So the correction is going to be the max. That's going to be a float. Penetration. So yeah, penetration we need to define SLP. Yeah, that's fine. That's fine. Divided by the inverse mass, which is just the manifold or the physics 1 inverse mass, and then physics 2 inverse mass. Wait, what's this one? That's right there. That's right there. Okay. Times the percentage, which is the... Wait, what's N? He doesn't even mention what N is. Oh wait, move each collision normal and by percentage. Oh, okay. That's the collision normal. Gotcha. That's the manifold normal. So we have the percentage, which is S, correction percentage times the manifold normal. Oh, whoops, that's just normal. And so the thing that sucks about this right now is that we have to do it twice. Because, right, all of that. Okay, so wait. It's all of that, and then we just have to multiply it by the N. So it probably makes sense to do it like this. Might actually just do it like that. What if we do correction? Because then that all that really is the correction times the normal x. Yeah, we don't even have to put parentheses in there. Times the normal y. And this is physics 1. Or actually, that's not right. That's going to be the transform, which we don't have access to right now. Yeah, this needs to be the transform component. Oh, whoops. That's my bad. That's what it was. We need to take the max of those two, right? The max of those two divided by the inverse, the sum of the inverse mass, which we're actually, I mean, I don't know if it really makes sense to store it, but we're also calculating that they're times the correction percentage, yeah, and then that's just multiplied by the correction times the normal x and y to set the, yeah, but this actually needs to be the transform. Oops, that would be 2. Transform 1 and 2. So that's for the correction, positional correction. Okay. So we need to do the same down here. Well, first I should probably finish this. So we know that we're always going to have a transform component. So I guess we have to get this. Didn't really realize I needed to do that transform component. We know we're always going to do that. This is bounds. Oh yeah, we have to do it twice, that's right. Multiplying it by the transform, yeah. It's 2, so we're technically doing this more than we need to. Oops. Yeah. Well, I guess in that case, oh no, we can't. Never mind. Never mind. So yeah, now we need to do it with the transform 2, which we don't have yet, which we will get up here. There's our transform 2. And then for this, we still need to do this, but we only do it for 1. We don't do it for both. And this inverse mass here is always going to be 0. So we just do that. And there we go. Okay, so I think we have that done. So the last thing we have to do is calculate the normal and the penetration for the manifold, which is really simple because we only deal with AABB. Whoops, it was this one right here. So this is how you can calculate the manifold and the penetration, although I think that these are kind of wrong. Because it's only doing this if it's greater than. So it only does the y, test on y is if it's greater than 0. This seems weird though. So it's like, in this case, we're just not setting the normal, period. Which seems very wrong. I don't think this code is right, like, at all. Yeah, I don't think that this code is right at all. Let's look if we can find like a better code sample for this. Is it plus equals for transform 2? Oh, you're right. Thank you. You're right. They need to be going in opposite directions whenever they intersect. So that for the positional, yeah. Yeah. It's not returning anything at all. It's doing a lot of weird things. Like, this guy, I would say he did a pretty good job with all of this. Like, you know, he has nice little graphics and everything, but like the code samples just are not well done. Was this like, this code doesn't make any sense whatsoever if you like actually read over it. And I saw some people complaining about it down here. I'm having some problems with this, yeah. Doesn't it mean that at least... Shouldn't we set the normal as 0, 1 or 0, negative 1 and the penetration as Y overlap? Yeah. And there's like a few issues with it. And then also like here he sets it the normal to 0, 0 whenever it really should be negative 1, 0 and 1, 0. So like that's wrong as well. And yeah. But separating axis theorem, yeah. Let's see if we can figure this out with this. Looking. This is way more complicated than we need. Okay, so that's... I don't know about that. I just want to make sure I do this the right way. I don't think I did it right for Korea. Let's see what this guy does. Polygon A, polygon B. Yeah, I think that... Yeah, the thing is about this is that ours is so much simpler. We can do something so much easier, right? Hey Bart, what's up? Doing some physics. Yeah, I don't think we need to do anything this complicated. Like this is working with polygons, convex shapes and everything, but it's like we're just wanting to work with axis aligned bounding boxes. We don't need any, we don't have complex shapes. If I actually took the time to read one of these, I could probably figure out the correct solution, though. Because there's a lot of things that it's going to be the same math. It's just you can make a lot of assumptions and cut corners. Like oftentimes the dot products will just end up being like 0 or 1. So it's like, or not the dot products, the calculating the normals. Maybe I can do SIT, or it's separating axis theorem with APB. Reading. Collision normals are trouble. And also finding the moment of first collision. Yeah, how is this? Finding the contact point with SAT. How to deal with corner collisions in 2D. Continuous collision detection. Running your physics multiple times. Yeah, what I just did would separate one in Korea, but I did run into issues with that. You're going to have so much fun with inside edge collisions. Oh yes. An absolute blast. Yeah, Korea had some problems with collision stuff, particularly with whenever it had slopes. And what would happen is that you would kind of be inside that slope, and then you would change the state of the slope while you were inside of it, and that would cause you to like fall into the ground or whatever. And once you were already inside of a collision area, that collision suddenly is like no longer valid, it wouldn't push you out of it. You would just kind of like fall through it. Binary searches the moment of collision. Interesting. Whew. That looks fun. Yeah, looks like we need to do some reading, huh? But it's all just A, B, B. No, I'm actually only doing axis aligned bounding boxes. Yeah. I decided, like, I looked over all of the use cases for the game, and it's just that it's just I don't need more. I looked at it, yeah, I was like, do I want, yeah, it just don't need it. So we're actually having the physics system be very simple, and that's, I think, fine. That's not, while it's like going to be used a lot, we're not doing like really complex physics. Yeah. Which is actually a good thing, because we want to use it a lot. We're going to be like throwing around items and doing a bunch of stuff, but like we don't need angular velocity. So that means that all of our, like, there's no rotation of objects from physics. And so all of our or everything can be axis aligned. Well, we don't really need circles, so I'm not going to do circles. I mean, maybe in the future I'll decide I need it, but right now I don't think I do. So we're just having it be rectangles. So yeah, should stay pretty simple. I need to calculate the normal and the penetration. Right now we could just say that the normal is always going to be 1, right? I don't know about that. Penetration, oh yeah, but it changes depending on if it's an X or Y axis. Yeah. Yeah, I need to do more. I need to calculate those, which requires me to do some stuff. Unknown override specifier. Okay, so it doesn't let me do that. Okay, so that doesn't work after all. Well, that's too bad. Does not support default int. Yeah. I was kind of doubtful that was going to work, but hopeful too. Oh yeah. Anytime that we're changing the bounds, that needs to be static cast. I wonder if I should make the position be a float. I am wondering about that. Yeah, I need to fix the null. I'll have to fix the null. We'll do that tomorrow. We'll do that tomorrow. I'll get this figured out. So we need to calculate the normal and penetration for this manifold. And then we need to fix the entity null. And that should be it. So yeah, that's going to be it for today. I need to get going. Thank you so much for joining. I really appreciate it. I'll be putting this VOD up soon. And then also, we did a recap earlier today. So for anyone who's like kind of newer or have missed some days, you can get a recap. Hey Baxter, sorry, just closing down here. But I have a recap going up on YouTube soon. Probably be up tomorrow. And yeah, we'll be back tomorrow morning, 8 a.m. Pacific time. We'll be working on finishing up this physics, hopefully, or at least getting like a really simple version of it working. And I think we'll probably also work on a better vector class or something, so that way we don't have to do this so much. Like, basically, we'll be able to cut the number of lines down in half, which will be good. Yeah, thanks, guys. I hope you all have a good rest of your day as well. Thanks. And I'll see you tomorrow. Have a good one. Bye.